Hello and welcome to Slooh. I'm Paul Cox, your host for this special live Slooh Star Party. And together with our special expert guests, we're going to be watching and learning about one of the most spectacular celestial events, a ring of fire solar eclipse. Now, over the course of the show, we're going to watch the moon's dark orb as it passes in front of the sun. We'll see the start of this in around 7 minutes. Yeah, about 7 minutes time. And we've got our live feed up. They've got a few clouds around at the moment, but not to worry. That won't matter. So anyway, that's about 7 minutes away. And the ring of fire is going to occur in about an hour and a half. So don't go anywhere. Now, if you're new to Slooh, we'll tell you a little bit about what we do here and how students and members control Slooh's huge mountain-top robotic telescopes as they learn about astronomy, with something else that we're going to show a little bit later, actually, with our interactive Quest learning activities, which are quite cool. I know we've got quite a few of our student members watching today. I know we've got quite a few of our educators in as well. And as you know, this is Slooh. So we've got some fabulous live telescope views of the eclipse from our partners and members. And don't forget, Slooh members can snap images from the primary feed to use in the special moments quest that we're going to tell you about in a second. Now, I mentioned expert guests, and my goodness, we have got a great lineup today. We're going to be talking to Slooh's Director of Curriculum, Dr. John Beauvert. He's going to be telling us about the special eclipse quest and give us an eclipse 101, kind of back to basics on these remarkable events. Slooh expert and summer camp leader, Keith Wozaleski, he's going to be joining us to talk about the different stages of a ring of fire eclipse and also some of the timings that we're going to be looking at today. Slooh expert member and quest author Milton Villarreal, he's going to be joining us to tell us about some eclipse legend and lore in South America. And it's not just about the science that we love here at Slooh. It's about how astronomy has been seen in history, culture, art, literature, music and mythology. And we're also extremely excited to have one of our students who participated in the Slooh's summer astronomy camp joining us today, a long-time student member, Misha. She's going to be giving us a presentation later about solar eclipses. And we've got several eyewitness reports coming in from all manner of places. We've got a group of students who use Slooh at the Chaparral High School, Scottsdale. They gathered to watch our broadcast and witness a partial solar eclipse in their location. Hi, everybody there. Looking forward to meeting some of you later. And Steve Millam, their teacher, who's gathered them up at the school over the weekend. So thanks for doing that, Steve. Leader of Slooh's professional development program, Russ Glenn, is going to be joining us as well from the Austin City Limits Music Festival. I'm a bit jealous of that one. He's watching that down there. Hopefully we're going to catch up with Russ later. We also hope to speak to Slooh member Nick Rotundo, who's providing our primary eclipse feed. Look at this. So we haven't started the eclipse yet, but that's a special telescope, and Nick's been sorting that out for us all morning. So we've got to watch. We'll be watching at 7 minutes past the first tiny little chunks being taken out of the sun. Now, what else have we got? We've also got Ron Hipschman from the Exploratorium. They're also providing two of our other feeds. So thank you very much, the Exploratorium, for doing that. We also have two fascinating interviews coming up. My goodness, we've got an awful lot to get through during this eclipse. We've got eclipse chaser and psychologist Dr. Kate Russo. She's going to be joining us to discuss her work to understand why and how these celestial events leave so many of us totally awestruck, especially total solar eclipses. Kate's going to tell us about her new program, which is called Project Awe, which I think is an absolutely superb name. We'll also be joined by Bob Baer, who runs the DEB initiative. We're hoping to have some of their feeds a little bit later as well. And that's going to be a fascinating one to talk about. So hopefully we'll see Bob Baer later. Don't forget, Slooh members, you can ask questions in the Star Party chat and Q&A, and make sure you start snapping images on the Slooh members event page so you can create your own personal eclipse posters. Well, it's going to be an action-packed show, so let's dive straight in. And I would like to welcome our first guest, Slooh's Director of Curriculum, Dr. John Bovair. So John, students and members use our online robotic telescopes to capture images of a myriad of celestial objects, not just solar eclipses, but we've also got a solar telescope. And they can use those images in what we call Quest learning activities. Before we do the Eclipse 101, can you tell us just a little bit more about Slooh Quest?
Absolutely. We have quests at Slooh, which, like you said, they're fun learning activities that surround different celestial objects that members can capture images of in Slooh's professional grade telescopes that are at premier sites worldwide. So we have telescopes spanning both hemispheres to catch the entire night sky. And members can come on and use the telescopes to capture images, to complete quests, and create infographic posters like the one that you see here. So all 7 of these lunar phases were captured with Slooh's telescopes. The images were edited by the member to crop them and put them in this special spot on the poster. And they even decided what elements they would like to edit and change on the poster as well.
So is there a quest? We mentioned it early, which is specifically to do with this Ring of Fire eclipse.
That's right. Yes, there is. We have a special moments quest. It's called the Ring of Fire Solar Eclipse 2023. And it's a quest that's going to give you a lot of the same information that you're going to learn here, but it's going to be a place where you'll be able to take all of the images that you're capturing with our special feeds right now from Nick Rotundo down in Texas, and you'll be able to use those to create a poster, which is on the left that you see here. You'll be able to add about up to 41 images to this poster. Wow. So you can design them and make a time lapse, so you can make a spiral, or just choose your favorite one and make that be the big centerpiece. Yeah. And I do want to point out really quickly that to get to this quest, when you're on the Slooh dashboard, you want to hit on the quest tab to get to the quest discovery page, and then you hit on where it says browse, and you'll be able to go to moments. And like it was on the page there just a moment ago, it'll be the first moments quest that you see. So
that's really cool, John. Thank you very much. And the reason why we were kind of squeezing that in early right now is because you need to start capturing images to stick in your quest. Now, what timing wise, from our main feed from Nick in El Dorado, Texas, we're going to first see the first little chunk of the moon bite into the sun at 20 minutes past the hour. But if we can go over to the Ely feed in Nevada whenever we can, because I know it's cloudy there, but we need to keep an eye open for when, oh dear, what are they up to down in Nevada? They've got clouds, so it should have started down there. So okay, well we'll wait until they get their feed sorted out there. But anyway, John, let's start. Let's go to our primary feed. Now, folks, if the screen goes black at any point, that's because in fact, at least three of the locations where feed's coming from today have got some partial clouds at the moment. So don't worry about that. Bide your time. We've got plenty of time to see all of it. So there is Ely. So John, can you see? So we've started the eclipse. This is why I'm pausing, because I'm looking very hard at this image. So it should have happened about a minute ago. The moon starting to touch over, but the beginning and ends of eclipse, we're going to talk about this with Keith later, can be quite difficult to spot. So who is going to be the first person? I bet it's in that chunk where the cloud's going over at the moment. What do you think, John?
I think so.
So this is from the Exploratorium. So we're going to be interviewing them later. Yes, I can see it. Can you see it on about the 2 o'clock position?
Oh, yes.
It was where the cloud was. It was. Oh, look at that. And that's really quite easy to see. Now, the next start of an eclipse is going to happen at the Valley of the Gods in Utah. And that's going to happen in about 1 minute's time. So if they have got that feed up, if it's not cloudy, then we can go to that. But the next one for our feed, this is when you really need to start snapping photos on the event page if you're a Slooh member for your quest at 20 past the hour, because that's the one that you can snap images from, and that's going to be full color as well. It's going to look so good, John. These posters, I am so looking forward to this. But I guess since the eclipse has officially started for us, it's time we learned about today's event, the Ring of Fire solar eclipse. So let's go back to basics. We've used the term so often already, but we haven't actually explained it. What is an eclipse?
So an eclipse is an event where one celestial body or spacecraft passes into the shadow of another. So the word is
yeah.
right.
we're like dogs seeing squirrels, aren't we? So this is the Valley of the Gods Utah feed has come up very, very different from the other feed, John, just while we explain it, because this is a hydrogen alpha view, and we'll maybe talk about this. We've got a little bit of a round table coming up, so whoever is controlling this telescope knows where it's going to happen. Is that it? I think we're seeing it. It is. Yeah, that's perfect timing. Look at that. Wow. And look, it's going to take out, you can see a little prominence coming off the edge of the sun. We'll explain about all of this as we go through. We've got plenty of time to explain all of this, but we mustn't miss any action, because the moon is about to snuff out that little prominence. Wow. I love celestial mechanics, don't you?
I do. This is amazing.
So, okay, John, carry on with your description about what is an eclipse then.
So the word eclipse derives from the ancient Greek noun that means darkening of a heavenly body. And so that's what we're seeing today, the darkening of the sun.
Okay. And you've got a diagram, haven't you, to pull up at the moment?
I do. And this is the same diagram that'll show up on your Ring of Fire eclipse infographic poster. And so this is what's happening right now. The moon is passing right between the sun and the earth, and it's casting a shadow on the surface. And what's really awesome is there's three parts to the shadow: an umbra, the anti-umbra, and the penumbra. And this special eclipse, a Ring of Fire, is when the anti-umbra is racing across the Earth's surface. So today, the anti-umbra is racing across, and we actually saw that already when we watched our feeds from the Exploratorium in Ely. We saw the shadow hit that location, and then a few minutes later, we were able to see in the other Exploratorium feed from Utah that the bite was starting to happen there. So we're watching the shadow race across the surface of the planet right now.
Exactly. And it's so easy to picture it then. And actually, we'll talk about this in our roundtable as well. One of the best things about witnessing an eclipse, especially when it's a total solar eclipse, but it would be the same as this. Look towards the east, right? And that shadow is approaching you, and you see it on the horizon. And it's this darkening, a little bit of cloud actually helps with this. And you see this, you actually see the shadow racing towards you, and then suddenly it engulfs your location, if hopefully you're in the pathway of that shadow. So, John, how wide is that shadow that the moon is casting?
That's a good question. If we could go to the next slide real quick. So the maximum width of the anti-umbral shadow is 209 kilometers or 130 miles, depending on which unit you like using.
And that's the small dot there, isn't it? In the animation. Yeah,
that's the small dot that's in the animation. So we're already, we've already seen it go from Nevada to Utah, but now we're going to wait and see. And what was it? 7 minutes it's going to be in Texas.
Yep, 20 past the hour, so 7 minutes time. So that's going to be a good one to look at.
So
go on. Sorry, John.
What's really awesome too about solar eclipses is it's really the only time that you can see a new moon phase. See a new moon phase.
So you mentioned that, but how often does solar eclipses occur? Because looking at that diagram, shouldn't we have, there's a new moon every month, so shouldn't we have a solar eclipse every month?
It would seem like it, but solar eclipses, we get about 2 to 5 of them each year, with a total solar eclipse, which is happening in next April, happens about once every 18 months. So we'll talk about total solar eclipses later on, but this diagram here, this is actually from our Mystery of the Changing Moon quest. And it shows an example of how the different lunar phases are. But like you mentioned, kind of implies that this new moon phase that we should always be having an eclipse. But unfortunately, that's not what happens. So in the next slide, what is happening is the moon's orbit is not perfectly aligned with the Earth's orbit as it goes around the sun. And so what this means is that sometimes when the moon is in a new moon phase, it's a little beneath the sun, and other times it's above the sun. But sometimes when everything in the celestial mechanics lines up perfectly, the moon will pass right between the Earth and the sun. And astronomers have a special name for that. When three bodies line up like that, they call it a syzygy.
It's one of my favorite words in astronomy, syzygy. Syzygy and oblate spheroids, which is the shape of Jupiter. So I love that a solar eclipse is really the only time we see a true new moon. You know, we so often think about a new moon as being a thin crescent, don't we? But it's not, you know, that's past. So other than actually the Moments quest, which hopefully members have already started today, are there any other quests that members should have a look at that they could use these eclipse images for?
There is. So in Mystery of the Changing Moon quest, you can learn all about eclipses, and also in Moon Shadow, you can learn all about eclipses. But we do talk about eclipses in the Lunar Phases quest, which was the first infographic poster that I showed today. And what you can do with your Ring of Fire eclipse image, your favorite one, you can actually add that to your infographic poster and be able to showcase all 8 of the lunar phases instead of just the 7 that we normally can see.
Okay. So, John, another aspect of this eclipses. So there's a number of solar eclipses every year. Why are they so challenging to see?
Well, if we can move to the one slide that, oh, wow, that's looking really great.
Looking good. In fact, the clouds are clearing in time. So
let's just go back to a mental image of the shadow path going across the Earth's surface.
Yeah, so that was that large S shape that was going over the red path, wasn't it?
Yes, that's right, that red path, and it's only 209 kilometers or 130 miles wide. In order to see one of these eclipses, these solar eclipses, you actually have to be within the shadow. So you have to be along the path of the eclipse in order to see it, which is awesome because we have 3 streaming partners that are providing these feeds today. We have our member Nick Rotundo in Texas, who is providing us the feeds that we should be snapping images of, which I've just snapped another image of myself, and our 2 feeds in Utah and Nevada from the Exploratorium.
That's great. So don't forget, at 20 past, we need to go over to our Texas feed from Nick in El Dorado, because so, John, that's the illustration, isn't it? You know, we can almost see from every location, you know, who hit the shadow first. But there was a larger area on that map that you showed us. We had the red path going through, and also on the animation, we saw a far larger shadow also moving across the surface of the Earth. So what do you see? You're saying you need to be in that red zone to see the annular ring of fire eclipse, but what do you see then? I think Steve Miller at Chaparral High School in Scottsdale, they're not in that path, they're just outside it. So what do you see if you're in that region?
Yeah, that's the penumbral region. And when you're there, instead of seeing the moon pass perfectly over the sun to get that beautiful ring of fire, it's going to be a little bit off center. So instead of seeing a ring, you may see what may look like maybe some horns, for example, which is what I'm going to see here where I'm at in Las Vegas. I'm going to be able to see a partial, and those are called partial solar eclipses. But
sorry, John. So the further away you are from the path, the less of the sun is going to be covered.
That's right. That's right. Okay. And so every blue line that you see going to the right and to the left of the red line on the map is it's 20% of the eclipse. So if you're near the first two red lines or two blue lines, and you'll see 80%, and then the next one is 60, 40, so on.
And our 3 feeds at the moment, that little red dot along the path of annularity hasn't reached them yet. They're still there. That's why they're only seeing a partial eclipse at the moment. But as you say, it is racing towards them. And we will have 1 hour to wait from now until the first site, Ely in Nevada, gets to annularity. And that's what we're going to see gradually cover. Look at this. It's going to be perfect timing. Right. Where is the chunk going to come from in our feed from Slooh member Nick Rotundo down in Texas, who's going to be the first to see it? Oh, I can see a nice prominence up there at a 2 o'clock position. Who's going to see it first? This is like, you know, when you drive to the sea and everybody in the car, they want to be the first one to see. Who sees the sea? Go on, where is it? Oh, that's a beautiful prominence. John, while we're waiting for this, tell us about the prominence. Oh, somebody has just said it's coming in from the top. In fact, Nick has just said, thanks, Nick, for messaging. Can you just see it? It just looks like it's flattened off a little bit.
It does, yeah.
Wow, that's subtle. That is so subtle. And we can see a lovely sunspot down there at about the kind of 7 o'clock position, lower left. So, oh yeah, you can see it a lot easier now. We're going to talk about the timing of this, because you could do some real science with this, couldn't you, John? You know, timing how long it's taking the moon to travel from one side to the other. I think we've got some quests that are doing that kind of measurement, and we've got some solar quests where students are measuring, aren't they, the rotation of the sun.
Yes, they're using Canary 5 solar telescope to take images of the sun throughout an entire week. And we make an animation watching the sun rotating on its axis, and then watch how different surface features like prominences, like we just mentioned, which are these massive eruptions of solar material that fly out into space and then rain back down onto the solar surface. They can watch these learn about and watch these regions evolve throughout the week, and estimate even what is the solar latitudes of the features as well.
Excellent. We've got a question coming in from Jeff. Jeff is saying, how do I take pictures since I'm not on the Slooh dashboard? Right. So Jeff, you should, if you're watching the show, you need to go to the event, the Star Party page. And if you're in the Zoom webinar, which you are, you won't want both of these things open at the same time. So you can pause the live show on the event page, and then you'll see another little tab which says El Dorado, Texas. And if you click on that, you'll see the live feed, and you can snap images from within there. So, John, if or actually Studio, if you have no, I don't think you've got that open, but we could show people. But anyway, John, we've got some time. Let's talk about that prominence that we're saying. What on earth is that? If we could go back to the Texas feed, what is that? So, by the way, Nick has said the clouds should be clearing very soon. So hopefully we're going to get a really clear eclipse there. So, John, what's the prominence and where is it?
So
difficult to see with the cloud.
Prominence, it was just a little difficult to see right now, but we've seen them in some of the other awesome feeds that we've been looking through already. These are massive eruptions that are happening on the sun's surface, where charged material are flying along local magnetic field lines and basically erupting a lot of hydrogen, very hot hydrogen, into space, and gravity grabs the sun's gravity grabs those things and pulls them back down, still along these magnetic field lines. So there's these magnetic fields that are kind of coming out of and going back into the sun that cause these beautiful surface features that we see here.
And we've seen such superb solar activity recently. Actually, a lot of people who are new to Slooh, tell them how Slooh members are able to watch the sun every single day. It's, you know, not just eclipses, it's every single day Slooh members get to see it.
Yeah, every single day, Slooh members get to see it's through our Canary 5 solar telescopes, and it's looking through an H alpha echelon. So we're getting an H alpha view of the sun, which was similar to the one that we saw from the Utah Exploratorium, where we saw all of those awesome surface features.
So what
So
does that mean, John? Hydrogen alpha. This is and you called it an Talon. It's a bit like a filter. It's operating like a filter. Hydrogen alpha, that sounds incredibly complicated.
it sounds complicated, but I promise it's not. So what happens is, what's really cool is all of the different elements on the periodic table, they emit specific wavelengths of light. And so you can actually use those wavelengths when you see them out in nature, in the medical field, outside. You can determine what atoms you're looking at by looking at the wavelengths. And so what's happening here, the sun is made mostly of hydrogen, and that hot hydrogen, when it moves around, it's giving off light. And the brightest wavelength of light that hydrogen gives is called hydrogen alpha. It's around like 656 nanometers wavelengths, right? It's a reddish pinkish color. And so with an H alpha echelon, it's perfect. It's a filter. So we're just looking at that one wavelength. And based on that information, we can see a lot of detail on the sun. We can watch where those hydrogen atoms are moving around, flying up into space and then raining back down onto the surface, or causing cooler
Coronal mass
regions to
ejections,
appear.
and there's all
Yes, and
manner of things
coronal
that we can
mass.
see. Yeah.
And so you can use Slooh's Canary 5 solar telescope to watch the sun for these coronal mass injections, for these different solar storms. And it's basically to make sure that, we're safe here on Earth if anything like that happens and flies our way.
Yeah, and I read only last week actually that through studies of some tree rings, that they've identified the largest solar storm ever, which happened a very long time ago. I think it was about 10,000 years, so please don't quote me on that. But they're saying that if a solar storm that great happened now and hit the Earth, it would wipe out just about every single electronic device on Earth. John, we still have some time, and while we've got you, I'd love to talk about that a little bit more. Earth has its own shield against a solar storm, doesn't it?
It does. It does. We have a magnetic field surrounding the Earth, which protects us from these events, most of these events. But if the solar storm is too much, then our magnetic field isn't going to be able to protect us. And this actually happened. This actually happened in the late 1800s. I think it was 1883, sometime in the 1880s. I want to say
the Carrington event.
It was the Carrington event, and this was a massive solar storm that went through Earth and flew by Earth. And at the time, we weren't so as reliant on electrical technology as we are now. But I mean, there were reports of lightning coming out of like electrical sockets back then, and computers going, I think technology going haywire.
The telegraph operators, I think, were the people who were at the end result of that. But so the magnetosphere, so we kind of know that Earth has this magnetosphere, and it's like a bar magnet almost. So we have, you can draw it, and it's like the magnetic field coming out of the North Pole and through to the South Pole, surrounding the entire Earth. So when all of these highly charged particles in a solar storm hit that, what happens to it? Does that magnetosphere kind of protect us, or does it channel those high energy particles anywhere in particular?
It's a very good question. So the magnetic field that's surrounding the Earth, so it's magnetically charged. The hydrogen that's coming in from these solar storms, they're also electronically charged. And so what happens is the magnetic field kind of has the charged material flow along the magnetic field that is like protecting the equator of the Earth more, but then it kind of falls into the polar regions, because that's actually the weakest part of our magnetic field. And this is actually causes the beautiful aurora borealis and aurora australis that that you can see if you're in latitudes near the poles.
These feeds are something else, aren't they? So this is Valley of the Gods, Utah. So this, John, is called a white light view. That last one, the kind of yellow orangey one that we saw, that was the hydrogen alpha that you were talking about. And we're looking at two different layers of the sun, aren't we? So this one is what you'd see if you look through some eclipse glasses. That's what a white light filter is doing. It's basically just stopping a lot of light hitting us. So can you explain the difference between these two different surfaces that we're seeing in the feeds?
Yeah, so in the H alpha feeds, we're able to see what's called the chromosphere, which is above a region called the photosphere. And when we're looking at the white light region, we're seeing the photosphere. And the reason why we're seeing the photosphere and the white light is because there's so many wavelengths of light coming to us, and our eyes and the telescopes are seeing all of them at once. And so when that happens, the photosphere is actually incredibly bright, and we can't really see the chromosphere. But when we have that H alpha echelon, that H alpha filter, that prevents most of that white light to getting into the telescopes, and that allows us to see the chromosphere where a lot of the action is happening, a lot of the solar action.
You can see this very clearly. So here we are on the photosphere view. So this is what you'd see if you were wearing eclipse glasses at the moment. And what we can see there are two giant sunspots, and these are visible on the photosphere, but hopefully they'll flick back to the H alpha view, this hydrogen alpha view. So we see the chromosphere again, and that's the layer on top. Now, sometimes, and we may even see the corresponding active regions, because they're normally brighter, and they can be called plages or active regions. Plage is French for beach.
Yes.
And the sunspot is underneath that. And I love that, because during the week, when we use the Canary 5 solar telescope, that's at the Institute of Astrophysics of the Canary Islands. If you want to know where Slooh's telescopes are, high on a mountaintop, high on a volcano in the Canary Islands, that sparks up every single day. And what we do when we tune that, when it starts off, we're looking at the photosphere. But then as we tune that strange filtering device that John talked about, we're slowly bringing up the layer of the sun that we're seeing, until in the end we're looking right over the top of the chromosphere. And this is when we see the active regions. We see these huge filaments stretching across. We see these huge prominences on the edge. And I'll tell you, some of those prominences that we've seen recently, I have never seen anything like it in all the years I've been solar observing. They were changing over seconds and just erupting and letting go, releasing huge quantities of solar mass, and it'd be millions and millions of tons, John, wouldn't it, of stuff, sun stuff, just being released into space. Now, when we see those on the edge of the sun, there's nothing to worry about, because we know they're going off into space. But when we see, so there are the three active regions there that we can see, and the one on the left actually is the one that's responsible for that larger sunspot. When we see one of those, sometimes we can see activity bubbling up, gets very, very bright, and then sometimes we actually see a burst of stuff. And when we see it on the face of the sun, that's when it can be heading towards us. John, operators of satellites, they're not keen, are they, on a lot of solar wind and solar particles hitting the Earth, are they?
They're definitely not. I mean, of course, they're still kind of within the magnetic field, but because they're not on the surface, they don't get as much shielding as we do, luckily. So satellite operators definitely get worried every time there's a solar storm that happens. And this is why we continually watch the sun for these solar flares, because once we see them, there's only a limited amount of time. So when we see the solar flares, typically it's a coronal mass injection. So there's actually particles, hot, energetic hydrogen particles, and also alpha particles are coming towards Earth. So we see them first, and then we only have a limited amount of time before the wave actually gets us. So continually monitoring the sun for these sorts of events.
And so some of these storms can be so strong that they actually heat the upper atmosphere. So our upper atmosphere actually increases in size, and the low Earth orbit satellites, they start getting dragged and they start losing altitude because of that. So the satellite operators, they have to use a little bit of the very limited fuel that most satellites are launched with. You can't fill them up, although I'm sure Mr. Musk will think of a way of doing that at some point. They have to expend some of that fuel to boost the satellite's altitude to get it back out of that slightly expanded atmosphere. So it can be dreadful, and we are in a very, very active period, aren't we, John, of solar activity?
We are. The sun goes through an 11-year cycle of activity and not so much activity, and it's actually related to the magnetic field surrounding the sun. So typically the magnetic fields are kind of uniform, similar to how they are on Earth, where they come out of the sun's poles and they go back into the bottom poles. But the sun is not a rigid body. The sun is plasma. And so when it rotates, and you'll see this when you go on the Our Rotating Star Quest and make the animation, different latitudes of the sun rotate at different rates. And this causes those magnetic field lines that start nice and beautiful to start to become tangled up with one another. And that tangling of the magnetic field lines is responsible for these active regions that we see on the sun. So after every 11 years, when everything gets all tangled up, it kind of releases all that energy and then goes back to being nice, quiescent, beautiful, smooth magnetic field lines. But then the process starts on over again.
John, we've got somebody asking in the webinar, how do I take pictures again? So if you go to the dashboard, when you log into Slooh, go to the dashboard, you'll see up at the top, join Star Party, go to that. It'll open up the Star Party Slooh Live page, and there's a big button in the top left-hand corner that says show. That's where you can actually watch the show itself. But then there's a little thing to the right of it. It's a circle, Slooh logo with a number 1 in it. It says El Dorado, Texas above it. If you click on that, it opens up the live feed, and then you've got the typical snap button that we've got on all of the telescopes. And just as I was doing that, I was only saying that, John, because I wanted an excuse, because that's the first time I've snapped an image so far. So I'm really looking forward to the posters. So remind us again, John, why we're encouraging members to snap images from this live feed from Nick Rotundo.
We have a special Ring of Fire 2023 quest that you can take up to 41 of your snapped images and include them onto the infographic poster. So that would be a good, if you haven't started capturing images using the snapping function on the Star Party page, definitely start now. This is going to be such an awesome poster to make. And once you make your poster, please share it in the community and let us see what awesome stuff that you're creating.
Yeah, especially the new custom poster feature that we've got, because you can personalize that however you like. You give a framework there for people to use if they want. But I have to say, John, this is one of my favorite partial eclipse feeds that we got, because this is a partial eclipse at the moment. It's annular phases in about, for this particular location, in an hour and 10 minutes. But we've got to wait about 40 minutes for our first annular shot. But I kind of love these clouds going through, because it makes it look so fiery.
It does. It really does. And it also reminds us that, we are looking at something that's happening live. We have the clouds. We can't tell the clouds to go away. So
it gives I think a little bit of cloud for an eclipse, just a little bit, is quite good, because it adds a dynamic nature. Otherwise you're kind of looking, especially with the white light feeds, you're just looking at a white circle being covered by a black circle. So John, I'm going to spring this question on, because I was thinking about it last night and I don't know the answer, and it's a difficult one. When is the moment of new moon? Because I was kind of thinking about it, that I think the moment of a new moon is not specific on a place, it's specific in time. But that would kind of, to me, my logic says, well, when each location is looking at the annular phase. In other words, you've got that syzygy, that word that you mentioned, the lining up of 3 celestial bodies. That would kind of say new moon. What do you think?
That's really good to think about. It's yeah, very subtle point. I've always thought that the new moon was when the sun and the moon share right ascension.
Okay, that would make sense then. That would make sense. Which then is going to be on this particular day, somewhere on that path, there is a midpoint. And that's when that is occurring. So if we look at that path, and they will have the greatest eclipse as well. We're going to talk about this a little bit more, types of eclipse in our round table when everybody's here, because you've got an annular eclipse, but that lovely animation that you showed, John, it shows the curvature of the Earth, and the shadow is the distance basically between the moon and the shadow is further away over there than it is there. It's a lot closer, and we can get something then called a hybrid eclipse. And I was fortunate to witness one of those in Africa on one of the Slooh eclipse expeditions, and the people before us and after us in that path saw an annular ring of fire eclipse, but we had a total eclipse in our location. Unfortunately, it only lasted 12 seconds of totality, but it was still worth the 4-day trip to get there. John, have you got anything else to add for us today? I know you've got to fly.
A couple of things. It's amazing that we could even see hybrid eclipses. There's the border there to be able to say which one is a ring of fire versus a solar eclipse is so small, and the fact that we can see those things are really great. On the animation, the dot that moves across, you can actually, if you look closely, you can actually see the width of that dot changing as it's moving across, and that's representative of this distance. So it's really amazing.
And the speed of the path the shadow takes, that changes as well across the course. But John, thank you so much. It's always fascinating to listen to your extensive knowledge of these things, and thank you very much. I think some of the stuff that we added in there, because strangely for us, we're ahead of time, so I think that was fascinating to hear about the hydrogen alpha versus white light and the different surface features that we're seeing in both. So John, thank you so much for joining us today. So if you are around later, please join us.
I will, and I hope everybody enjoys the eclipse. Don't forget to snap pictures for your poster.
Yes, and share the posters as well. I'm dying to see those. I mean, this is what makes Slooh so unique. It's not, we don't do this just for events like this, one-off events like this. We do this every single day, every single week. We've got students, members using our robotically controlled telescopes high in the mountains of Chile and the Canary Islands. Now, one aspect of astronomy that we love here at Slooh is that it's not just about the science, or we don't think it is anyway. Many of our quests look at astronomy through the lens of art or literature, history, culture. And that's what we're going to talk about now, as we still watch the moon slowly enveloping the sun, which I absolutely love. I mean, and this is all going to make sense in a minute, because there's some lovely stories about this very event and what we're witnessing. So what we're going to talk about now with our next guest, he's a long-time Slooh member, an educator and lecturer, and his native culture studies led him to specialize in archaeoastronomy. We'll actually ask him, I think, what archaeoastronomy is in South and Central America. I would like to welcome Milton Villarol to the Star Party. Welcome, Milton.
Thank you, Paul, and thanks everybody for being here. It's always a pleasure to bring this side of astronomy to your audience and capture their interest in this, right? Because the skies have always been there, and our ancestors have always wondered what is up there. So,
and we're doing what those ancestors did. We're gathering around, in our case, we're gathering around telescopes in a virtual world, but so often they would be gathering around, a campfire with stories of, what's happening in the sky. But you've got a particular story that I think you're going to say. What did the Maya think about solar eclipses? What did they think they were?
Well, I brought these stories for you today because if we review the path of this particular eclipse, it will hit the Yucatan Peninsula right on top. Okay, if you go
Okay.
to the next slide, you will see exactly that.
Ah, okay. Yes, yes.
So you can see the Yucatan Peninsula is exactly on the spot, and I can just imagine how people are living this in Mexico right now. Tourism must be going crazy because everybody wanted to see the clips where the Maya culture flourished
Yeah.
so many years ago. And so, to answer your question, the Maya thought that everything above the canopy of the jungle was, sky, was ethereal, and so, anything coming from there must be coming from the gods. That's how they envisioned all the eclipses, and that's why they gave it so much importance.
What did they think about annular eclipses? Was there anything about annular eclipses that they thought of? I
Oh,
mean, could they
definitely.
witness an annular eclipse? Because obviously the sun's so bright, and nobody watching this today should be staring at the sun with naked eyes. So could they even see it?
They could. If you go to the next slide I prepared for you, you will see exactly this cosmovision of the
Oh,
Maya.
wonderful.
And yeah, and this thing repeats itself in cultures in South and Central America. Everything above the canopy of the trees was the upper world, right? This
Okay.
is where the gods lived. And anything below, exactly at Yucatan, for example, you have the face of the earth, and anything under it was coming from the underworld. And you see these crocodiles there. They thought that when eclipses in general happened, these crocodiles would, try to eat the sun. And this is repetitive in many cultures in South America. In South America, it was a jaguar. The
Yeah.
Maya thought it's a crocodile coming up for the sun and taking a bite out of it, as we can see that now in our live feed.
And Slooh members can watch. Did we talk about it? I think on the lunar eclipse show. There was a fairly recent Star Party, Milton, where you told us about the Jaguar story, which is one of my favorites. I think. Was that a lunar eclipse or was that a solar eclipse when we were talking about that?
Well, the jaguar basically menaces all the stars or the sky objects, right? So yes, during a lunar eclipse, they thought the jaguar was attacking their goddess moon, and of course, during a solar eclipse, it was the same jaguar trying to take a bite of our sun.
Okay, and
In
when
both
we see the
cases,
live, when we see the live feeds, it's so obvious, isn't it? That's what you'd think. We can't see that it's the moon, and we can see it just looks like something has just taken a giant bite out of the
yes,
sun.
it is incredible to see that the cultures all over the Americas share some of this view, and these are cultures that flourished completely isolated from each other. And so it's basically a very human feeling to see that something is menacing our celestial objects that way. And obviously, because of the fauna of the region, you can imagine it's all kinds of predators.
How long ago are we talking in history here, Milton?
We're talking about more than 900 years ago when the Maya flourished in the Yucatan and also the rest of the jungle in South Central America.
So I can imagine the fear that they would have if they're just sowing the fields, doing whatever they're doing, and then suddenly they start to witness this event. But 900 years ago, were they even able to predict the occurrence of eclipses back then?
Oh, yes, they did. And what calls my attention, especially in the Maya culture, is that they were able to calendarize all this. If studio can give me the next slide, please. I'll show you one incredible way in which they kept track of time.
Gosh, I haven't seen this before.
Yeah, it's a very interesting representation in which, for example, the Maya believed in 13 lunar months, not the 12 that we are accustomed to, and also, a different progression of their own, let's call them stars in the sky. And so each of these months represented an animal and a number. And by keeping this for a long, long time, believe me, it's observations for a long time, they were able to actually put two and two together and say, hey, this kind of eclipses will repeat themselves here and here and here. And they
Wow.
were basically off by maybe a day or two, nothing really to envy our modern technology.
Wow. I just always find that kind of stuff mind-blowing, that it was possible to do. As you know, I live about 10 miles away from Stonehenge in the southwest of England. And I look at that and it's just generational after generation. And here it's captured in writing. At Stonehenge, they couldn't write this down. All of the learning, it was kind of intellectual property that had to be passed down from one generation to another. And so often in story form, because humans can remember a story, and that's what you brought us with so many of these stories.
Yes.
But what role did eclipses have in Maya cosmology?
Well, unfortunately, they never thought an eclipse was a good omen. It was all the opposite. It was something bad was going to happen. They thought that when the sun, which was their main god, right, was completely obliterated by the eclipse, a worldwide tragedy would happen. To them, their world was the jungle. Here, in this next slide, what you see is precisely this animal coming from the underworld. It could be either a crocodile or one of these snakes that is actually about to take a bite of the sun. The central image shows what they thought about the sun. And interestingly, you can see exactly what we see in our live feed right now, a darker area and an illuminated area. That's trying to show everybody that this is going to happen. And eventually, if they fight it with crying and shouting and, all kinds of noise, they will, chase away this creature that is menacing our main god. Above the sun, you see the scripture that says this is the sky or the heavens where the gods reside.
Okay. I mean, all of the eclipses, we spoke about it, didn't we, when, jaguars attacking the moon and it turns blood red, and, they shout, they do everything else that they're doing. And of course it worked. As far as they were concerned, what they were doing worked. And then of course you do it the next time as well. Oh no, they predicted it. It happens. They shout, do whatever else they want to do. And yeah, the animal goes away again and it reemerges. And this is what we're going to be seeing today, isn't it, Milton? I mean, we can so clearly see, we'll go back to the live images soon, I hope. And it's so clear. You can see exactly what they were thinking. And, I think it's very romantic, actually, these stories.
The Maya had a very complex culture, and all those lines and dots that you see are their number system. Their way of, calendarizing all these events. For those who are having Maya 101, every dot is 1 unit and every line is 5 units. So you can see, you can really see what all those numbers will be. On the on the left, for example, the first one is 8, 8, and 7. To them, those numbers meant, when probably the next eclipse would happen or this eclipse happened. And what is sad about this story is that a lot of this writing has been completely erased from the face of Earth by the Conquista. They didn't really understand what they were having, and they completely destroyed a lot of this. These ones were saved by explorers who took them back to Europe, and that's the only way we have this beautiful material to analyze.
I was thinking that just before you said it, how amazing it is that a document like this survives this period of time. It is amazing, isn't it?
Yeah, it was fortunate that we can have this, but of course, as you can see, it's like having a jigsaw puzzle with more than half of the pieces missing. And so all we can do is try to interpret, what may be happening. In our particular event tonight, and just to answer a previous question you had about archaeoastronomy, all this was thanks to keeping track of all celestial events and putting them on paper and trying to, in a way, guess or guesstimate, as we can say, when this will happen again. And over the course of the years, you could see, that some events would replicate and replicate, and it takes a long, long time of observation to really understand what goes on up there.
Yeah, to spot those repeating patterns. Milton, we're going to move on, but have you got anything else that you need to tell us about?
I have just one more slide that answers your last question.
Oh, yeah.
This is what we are about to see. Sorry for the spoiler, but I had to mention that for them, this was the eye of the sun looking directly at you in that very moment.
Okay.
And so
you can see why they would think that. So
yes, exactly. It looks like one eye, and it was the eye of the sun that I hope we will have a good view from our Slooh telescopes live feed. And I wish everybody the same awe that people will experiment at the Yucatan Peninsula.
Thank you, Milton. You're going to be joining us, I think, for our round table, but thank you very much for that fascinating
Absolutely.
segment.
Thank you for having me.
Now let's have a look at the live feeds. Here we are, Valley of the Gods, Utah, the Exploratorium feed. How are we doing for timing? Right, this is Ely, Nevada. So this is going to be the first one that reaches annularity of the three main feeds that we've got. And annularity, the ring of fire moment, is going to last for them about 4 minutes, 3 minutes, and that's going to start at 24 minutes past the hour, so a little over half an hour. This is going to be the last annular location that we see, and this is Nick Rotundo at El Dorado, Texas. Thank you very much, Nick. Nick is a long-time Slooh member, uses our robotic telescopes every night, but Nick also does quite a lot of astrophotography himself. And gosh, Nick, thank you so much, because he even went out and bought a new telescope so he could bring us this today. And it's a smashing feed. We can still see that prominence that Dr. John Bovair, Director of Curriculum here at Slooh, was telling us about up the top there. So that's looking rather nice. So this is when I think the eclipse gets really interesting, when we start seeing the sun change shape like this. And I know one of our next guests is going to maybe talk about something called the horns. And if you picture this getting deeper and deeper into the eclipse, I think you can see where that one's going, which is going to be quite good. Have we got Valley of the Gods that we can bring up at all? Because that is going to be the middle one. So 24 minutes past the hour, we're going to see the annular phase ring of fire at Ely, Nevada. Then a couple of minutes later, 29 minutes past the hour, Valley of the Gods, Utah. That's a lovely feed, isn't it? Look at that, nearly halfway through. And we can see the progress. We can see this time difference that we're talking about now. So 29 minutes past the hour, they've got about 4 minutes when the moon's shadow, the moon's disk, is right center in the sun. They've got about 4 minutes there. And then going back to Nick's feed, we'll have, well, that's 46 minutes past the hour. So we're kind of in the big hour of this ring of fire eclipse. Now we're going to invite all of our guests back into a little round table in a minute. But given that we're only 20 minutes away from our first ring of fire moment, let's take a few minutes to talk about these different stages of an eclipse. And to help us understand this, I'd like to welcome Slooh community expert and educator, Keith Wazalewski. And Keith also ran Slooh astronomy camp over the summer, which was pretty cool. Keith, welcome to the show. What do you make of the images we've been watching so far?
Thank you, Paul, for having me. The images have been incredible. Wow. The Valley of the Gods, I especially like. We've got the granulation in the sun. We see some filaments, and then we've got Nick's wonderful feed from Texas. Just incredible, incredible images. A really great event. I get very excited about any time there's an eclipse. And, the Ring of Fire eclipse is that one of three types. And to me, it's the most rare because we don't get to see this very often.
So actually, we've got some time here, Keith. Before we explore the different stages of eclipse, and why is an annular eclipse a lot rarer than others?
Well, in order to have an eclipse at all, we have to have the eclipse condition, but we also have that variable of where the moon is in relation to its closeness to the Earth. So when the Earth is, when the moon is closer to the Earth, we'll have a total eclipse. But when it's further away, we have this ring of fire because the moon is not going to fully cover the face of the sun. And depending on how far away it is, will determine how big that ring of fire is and what kind of phenomena we can expect to see. So, we can talk about the magnitude, which is how much of the sun is covered by the moon. This is going to be very close to a magnitude similar to totality. So it's going to be interesting to see if we're going to see some of these phenomena like Bailey's beads. You talked about the horns. We'll talk about that when we talk about the stages. It's going to be very, very interesting. And, every eclipse is different. We don't know from really moment to moment or location to location what we're going to see. You talked about how that first contact can be difficult to see. A lot of that has to do with the atmosphere. The moon and the sun, if they're rising by the horizon, we don't have a very crisp edge like we do have here. A lot of times it can be fuzzy, it can be hazy. We've seen this cloud cover that actually, obstructed that first contact in one of the feeds we looked at. And it was also kind of hazy, kind of fuzzy, probably because of where it was, in relation to the horizon.
And I think we saw the effect that you were just talking about on the Valley of the Gods feed. We could see the rippling edge of the moon, and that's the heat of the day, and it's the heat and convection of the air around the telescope. But also some of that was such a finely focused image just then that I think you could possibly see there was the edge of the moon, the limb of the moon isn't smooth. We'll talk about Bailey's beads later, because there has been a lot of there we can see it. I wonder how much of that is shaking atmosphere. I suspect quite a lot of it, the bubbling you can see, but I suspect some of those are also hills and valleys.
It could be. We're also, when you look at this image, we're also zoomed in a lot. And whenever you increase magnification, you're also increasing whatever turbulence and whatever we have in the atmosphere. So we could have some of that going on there. But to your point, the lunar surface is not smooth. There are peaks and there are valleys and there are craters and crater walls. And interesting here, we're going to see it on the trailing edge of the moon if we see Bailey's beads at all. Now, I know, had trained as an architect and have a very good eye for lining things up and measuring things. So when we look at the sun, we're starting at the edge of the moon. It's not going to completely cover the sun. We're starting to see that here.
So you talked about, Keith, sorry to interrupt, you talked about the first stage already. I think you said first contact. So that's not the great Star Trek film. So that first contact was the first stage of the eclipse. It's the first bit that we see, is when you see that tiny little chunk. What are the other stages then of an eclipse? And we can talk about total eclipses or annular, whichever, but there are basically 4 or 5 stages?
The 4 stages. So we're still technically under that period of first contact, which is the partial stage. First contact is really, when you get that first bite out of the moon, but it will continue all the way along until, we reach that phase of the Ring of Fire, until we reach Annularity. So we're still definitely within it. I'd like to get a full sun picture if we can, because we're seeing the moon move across the face of the sun. Don't forget, the moon is in orbit around the Earth. you have that syzygy, as Dr. John talked about, that lineup of the Earth and the Sun, and the Moon is moving this way, and that's why we see that chunk coming from the right. Okay, so here's the big speed. This is perfect. So, we're seeing very clearly that we're approaching this stage of the Ring of Fire of annularity, where the Moon is moving across the face of the Sun. We are seeing the very big chunk, and that chunk's going to get bigger. We don't see it as much here, but as the Moon progresses, we're going to see that effect that we think of as being horns, where the Sun outer rim is going to envelop the Moon in the middle, just that right spot where we see the rings start to develop. And if we see them at all, that's where we'll have the opportunity to maybe see Bailey speeds just before the Moon completely moves in front of the face of the Sun, and that's caused by those peaks and valleys and imperfections in the lunar surface.
And is that marking then the second stage?
That would be
contact.
Yeah, the second stage is that second contact. The second stage of the eclipse is that period of totality, or in our instance, in our case, that Ring of Fire annularity. The annulus, right? We're going to see the ring. That's the Latin word for ring, annulus. That's where we get the name from. So
I do think actually that my favorite part of an annular eclipse isn't actually the Ring of Fire. I do kind of like the horns, because sometimes that can get so close to being the full circle, and it does look absolutely marvelous. So we haven't got long to wait. We've only got about 15 minutes before we see that.
Yeah, it's very cool to watch, because they grow, as the Moon moves across the face of the Sun, they get bigger and bigger and bigger, until just before the Moon moves across and moves into the ring, the horns may start to break up. We'll see that beating effect. And I think that because the Moon is closer in size to the Sun, even though we're going to have the Ring of Fire, we're going to have a larger surface area, so we may have a more pronounced effect. But we have to see. I'm not making any promises, but again, every eclipse is different, so it's going to be interesting to watch.
Exactly. And the nice thing today is that we've got 3 chances to observe this, because each one of our sites is, don't forget, Dr. John was telling us about that path, that shadow, the Moon shadow is racing across the United States at the moment. Everybody out of that path is only seeing a partial eclipse. Anybody who's within that path is going to see the Ring of Fire annular eclipse. And when we talk, we're going to talk later about this, next April 2024, the total solar eclipse. Oh my goodness, you have to travel into the path of totality, because there's no comparison between seeing a 99.9% eclipse versus seeing totality. It is a totally different experience, and we're going to be talking to Dr. Kate Russo, psychologist, eclipse chaser, and also her new project, or a little bit later. But so we've got then, Keith, the first 2 phases. So we've got the first contact, which is when we just see the first limb of the Moon eat into the Sun. We've got the second contact, which is its kind of trailing edge, if you like, making contact with the Sun. Then we've got that third stage, which you were saying is either the annular phase or totality phase. So it's going to be annular today. So I guess stages 4 and 5 are once again when one edge of the Moon is leaving one edge of the Sun. Is that right?
Yeah, exactly. But I'm glad you raised a point here about where you are in relationship to the path of annularity, because not all annularity locations are created equal. Just like if you are outside of the path of annularity, you're going to see partial eclipse. If you aren't in that exact precise spot to see the Moon centered in the center of the Sun, you're going to have kind of a lopsided annularity. So we talked about that a little bit earlier. If you're a person who's bothered by not seeing things centered, this may be difficult to watch. I may have to lie down after this, depending on where the Sun is centered in where the Moon is centered in the Sun. So
I'm with you, Keith. I'm with you. So we're talking about this path of annularity, this Moon shadow passing across, and what we're talking about here is if you are right in the center of that path, then you're going to see a perfect alignment. But a few miles or one side or the other, and you're going to start seeing the moon's disk is going to be offset to the sun. So Keith, anything else to add about the stages, the timings? We've already kind of gone over. Where are we? We're about 10, 13 minutes away, something like that. And it's going to be Ely. So just to remind everybody, Ely, I think, is that how you pronounce it? Ely or Eli, Nevada. You can see very clearly, here's the illustration. That's the deepest eclipse that we've got at the moment, and they are going to be first to hit an annular ring of fire eclipse. And that's going to happen at 23 minutes and 56 seconds after the hour. So about 12 minutes time, 13, 14 minutes time, actually. And it's quite interesting, actually, when you see these, we've got the timing down to the seconds, but, once again, it's really difficult to time it. Then we got 6 minutes after that, we got Valley of the Gods in Utah. So we're not going to have much time in between. They actually don't cross over. There's about 2 minutes between one of them ending, Ely ending, and then Utah starting. But then we've got a lovely 10-minute period when we can talk about what we've seen on the first two while we wait for El Dorado, Texas, and Nick's feed, Slooh member Nick Rotundo down there doing a great job for us. And we've been pretty lucky because at the start of this eclipse, I don't know if you recall, we weren't seeing much of the sun because actually there were some quite heavy clouds around, but they look to have dispersed at the moment. And we're just seeing here, Keith, the moon covering one of those very active regions on the sun that we've been enjoying in the Slooh solar telescope all week.
Yeah, there's all kinds of great stuff happening, and we're starting to definitely see the horns beginning to grow, especially in these earlier feeds, the ones that are going to see it first. We're going to be able to watch that live as a group. It's going to be very exciting in the roundtable to see that and to see if those tips of the horns break up a little bit as
it's going to be fascinating. Well, let's kick off the round table then. So I'm going to invite back, if Dr. John Bover is still here, Milton Villarreal is still here, and Gretchen. We haven't seen Gretchen yet, but Gretchen Bickert is our events manager. She's put all of this on for us, done an absolutely brilliant job, lined up all of our guests, lined up all of our feeds. So, folks, Milton, you got your hand up. What have you got to say?
Well, I wanted to comment on what you just said about the weather. For all the scientists out there, I think this is something we should study because, in many of the events that I have witnessed, it started cloudy and it cleared up just in the moment. So I just wonder if it has to do with alignment, if it has to do with just everybody wishing the clouds were moved away or something else.
Yeah. So somebody's asking what's the round table? The round table is just with anybody, any of the panelists who are here. They can open up their video, open up their mics, and we can just talk and share these moments of annularity, which are going to occur. We've got 3 of them, and they're going to occur over the next 30 minutes. And we can talk about anything we like during this moment. So any members who are in Zoom chat, if you've got any questions that you want to ask us or any talking points that you'd like us to have a chat about. But here we've got that wonderful illustration of the horns starting. This is going to be great to watch with 3 of these to watch. I can't recall actually seeing bang, 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 in one of our eclipse shows, having 3 lots of annularity to enjoy. So maybe actually I'll throw over to Gretchen. Gretchen, how is everything? You're doing an absolutely marvelous job getting all of these feeds up for us.
Oh, thanks, Paul. Appreciate that. It's going great. I couldn't be more pleased with the responses we got from our feed partners and everybody working together and collaborating, because to me, that's really what eclipses are all about. Just this whole connection, collaboration coming together. So yeah, it's looking good. I'm excited for Annularity. I can't wait.
It is. It's so nerve-wracking, doing these events, because you're never sure. Are we going to be able to see it at all? And we were talking earlier, why are these so difficult to see? Well, to see an annular eclipse, to see a total eclipse of the sun, you have to be within that narrow path. And within that narrow path, a lot of that path actually is often over the ocean. So you pretty darn difficult to see that.
Well, I mean, unless you're on a cruise ship like Antarctica, didn't they take a ship out?
Yeah. So that they do that, but that's, you know, that's not accessible.
Exactly.
So, you know, a lot of the time that path isn't even crossing land. But this is why the eclipse a few years ago in North America, this eclipse, and especially April 2024 eclipse, is so good, because that path of totality and annularity is crossing one of the most populous areas in the world. So it's kind of quite fortuitous, and this is a great kind of intro to April 2024, but I'll open it up to others. This annular eclipse is very, very different, isn't it, to a total solar eclipse?
Well, yes, absolutely, because I love them both. I can't say which one I love more, but this is just so beautiful to see the ring when it comes, you know, spoiler alert, but yeah, it's completely different, but equally as phenomenal. So
I think it's great that they're happening around this way. And whoever sees this, if you are awestruck by what we're looking at and just the celestial mechanics, just seeing celestial mechanics like this in action, I love seeing that. I love seeing the illustration of what nature's putting on for us. But if you get excited about this, my goodness, wait until you experience totality. We are going to talk to Dr. Kate Russo about this later, but every time I've been fortunate enough to witness totality, it has literally brought me to my knees and I'm in tears. The most profoundly big effect on me emotionally when you actually witness that. Now, I don't think the same, I don't know, anybody else, you know, have you witnessed or had the same kind of feelings to an annular eclipse? Keith, Milton, Gretchen?
I've seen two. Oh, go ahead, Milton. I'm sorry.
Oh, thank you, Keith. Thank you. I just wanted to say that I completely agree with Paul in the sense that watching a solar eclipse really touches you deeply. And, you know, I've only watched one, but I know I will remember it for the rest of my life because it's an event that really, you know, hits very hard on your emotions and, you know, how small you feel against the whole universe.
Yeah. Keith?
Yeah, as I said, I've seen two under very different circumstances. One was when I was very young, and it actually happened right from our front yard, and the other I was on the road. But yeah, it is overwhelming. I mean, oh, here we've got a great view of the horns. You can see them growing, and I'm with you, Paul. You know, being able to see, you know, live some things that, you know, we normally only see in pictures. The fact that the moon is not going to cover the sun, different than a total eclipse, proves that it's at a different distance from us, you know, at different times. And we don't need to compare pictures. Here we see it, you know, live and up front and in person. And it's just a great, beautiful thing to see.
Exactly.
I like both. You know, this is not quite the same experience because you cannot look at this. You know, if anybody is at home, please don't go out and think you can see this without protective equipment. So, you know, you do have that filter, of course, with a total eclipse. You don't need that. So it's awe-inspiring in a different way. I get just as much out of this as I do from it.
I do. And whenever we're watching these events together like this, I always go back to Milton's stories and think how truly awe-inspiring this must have been to our ancestors when they didn't have the same understanding that we have of them. You know, we can time this down to the second. We know that it's going to come back, but they didn't know that, you know. And I love that kind of thought train going through, you know. And it's a lot of celestial events. You were talking, Milton, about them seeing this as a bad omen. Well, comets were seen by many places and many cultures as harbingers of doom. But was it Genghis Khan was the only person who kind of thought that a comet was a good thing? He thought he was going to win a battle, didn't he?
I guess you're right. But of course, at the same time, it's good for the winner and bad for the conquered.
Yeah. So here we are. So we're kind of edging up. We are now 3-4 minutes away from the annular phase from Ely, Nevada. And I think one thing, Keith, that's going to be quite interesting here is two things that you were mentioning earlier. One is, how close to that center line is it going to be? So is it going to be perfectly centered in there? But also, I'm going to be interested to see if we think about that eclipse path. The first one, the moon shadow, is going to be smaller. So we should see a larger ring, shouldn't we? Am I thinking about that right?
Yeah, if you notice the charts, the length of annularity actually will change depending on where you are. We're going to see, we also have that atmospheric element to throw at it too. So, we're going to see, is that going to have an effect? And then, where the moon is, yes. I mean, I don't have predictions. I ran some predictions on this and they were kind of inconclusive. We'd have to observe it. I think that's one of the beautiful things about astronomy. A lot of the sites said that we can only predict up to a certain point because everything is moving at a different speed. There isn't a constant really anywhere. There are nothing but variables. Where you're observing from is an issue. If you're in the mountains versus, at sea level. Wow.
This is just looking great now, isn't it?
Yeah.
We've got a question.
This is nice and crisp. I mean,
It is. We've got a question from Donna. So she's snapping pictures. So don't forget, Slooh members, you can be snapping images from Slooh members Nick Rotundo's feed in El Dorado. So you can snap those pictures. And she's asking, how do you then make the poster? Well, if you go back to the dashboard and go to Quest, you'll find the New Moments Quest, which is the 2023 Ring of Fire Eclipse Quest. And if you go into that quest, you'll find that you can insert, I think John was saying earlier, up to 41 of your images to create your poster. So I hope I've answered that. Heather Gunsel is asking, I missed a conversation about the high speed changes that appear to be on the surface of the sun in one of the views. Is that really celestial clouds or distortion? It's not celestial clouds, that's actually our atmosphere, that when we see it all bubbling like that, and we saw the limb of the sun in that close-up view kind of bubbling. But what I did notice when we were looking at that was there were a couple of peaks on the limb of the moon that we saw there that weren't changing with that rippling. So I think we were seeing some mountain ranges on the moon. So here we go, Keith. This is that illustration of the horns. We're
getting so exciting, to watch it just
seconds.
Inch over, right? Like I can't look away.
Yeah, I'm going full screen for this. Excuse me. I've got to be a little bit selfish. I've got to go full screen on this one. Oh, look at it.
It's like watching the flame slowly rise. We're watching that ring get big. Oh, wow.
Oh, that's fantastic. That's a great view. I like that.
Will appear.
So the official timing is 54.
That ring starts to break up. And you can see a crescent moon image where the limb is continuous. It breaks up a little bit. Wrong change.
So yeah, we don't want to see the prominence, even though it is rather interesting.
Right. So back to the other.
Just see it going up. So about another 20 seconds is the forecast moment for this location to start. And don't forget, when we see the whole ring, that's the start of the annular phase of this eclipse. It's going to last, I think it was about 2 minutes or something like that, maybe 3 minutes. About 3 minutes for Ely in Nevada. This feed is coming to us from our event partners at the Exploratorium. Here we go. It's 54 seconds was forecast. Are we going to see it? Are we going to see it? Well, we're past it. I can't see it joining up yet. How about you guys?
Just wait. I think we just need it to go just a little.
It does.
I think it's there, isn't it? Is that there? Yes. That's what I love. Every time we do this, everybody sees it in a slightly different moment, though. And there we are. So this is white light feed.
Wow.
So the less impressive, but hopefully we'll go back. We're going to see. I think Nick's annular phase is going to look the absolute best, because
well, I'm super excited, Paul. We get to see it 3 times.
I know, exactly. Yeah, not just once, but 3 times. So, gosh, beautiful.
Wow, that's just amazing.
Keith, can you spot yet how offset this is? I think there is an offset, isn't there? I think it's biased to the left.
Our feeds are coming from professionals. I have total confidence they are going to be dead center. Right now, we're just waiting for the moon to move across the face of the sun, and we've got almost 4 minutes to enjoy it. It's beautiful, absolutely beautiful.
That's the only time we get to see these new moons. That's the phase that it's in right now.
See, that's the beauty of, I believe, I feel like the annular eclipse is you get to like actually stare at this marriage between the sun and the moon, or a partnership, whatever we want to call it. But right there, and you get to see this little mini moon and the sun, and you only get to see that in an annular, right? Totality is awesome, but totally different. Totally, no pun intended. Pun intended.
I think the nice thing here too is when we see the new moon, we have to think that this is the same moon that we see at the full moon. It's just that it isn't illuminated. The same features are there, Mare Cruzium and Mare Tranquillitatis and all the beautiful craters and all the lunar features that we think of when the moon is at opposition over here at the full moon is exactly the same thing we're seeing here. Except it's not illuminated. It appears because it's between the Earth and
it was
the sun.
Only 3 days ago that we set up special missions. So a mission on Slooh is when one student or member is controlling the telescope to look at a specific object. We set up some special missions just 3 days ago to capture this tiny crescent moon, and it was so thin. I think it was only 6% phase or something like that. And Dr. John Beauvais was telling us earlier about our lunar phase quests, these learning activities that you can do on Slooh. So you capture your images of each lunar phase throughout a lunar month, and you piece together your own poster and you learn about lunar phases and stuff like this. And Dr. John was suggesting make sure you snap images from the live feeds today so that you can actually include a box which is normally left empty, which is new moon. And this is what you can put in that place. I reckon, Keith, they're not on the center line, are they? That's been biased all the time up to the top left.
I think it's moving across the face of the sun. We're going to move out of annularity and we're going to move into
so 27:35 is the moment. So now that's when officially the timing says, yep, it's no longer an annular phase. But I think
the moon is moving off.
That is beautiful. It's just it's a beautiful shape, isn't it? I love offset circles like that.
Yeah, it's
wow.
And it's only during an annular eclipse during the Ring of Fire that we get to see this type of shape. I mean, that beautiful circle with you know, the top part missing as the moon makes its way out. Third contact, we're moving back into the partial phase.
Amazing. So our next timing is 29:26. So in 1 minute's time, we are going to see this. I think this is going to be a pretty good one. Valley of the Gods, Utah, Exploratorium second feed for us. So this is down the line. So don't forget, we've got the moon shadow racing across the United States of America. It has just left Nevada, and it is just arriving very, very shortly in Utah at 29:30:26. So, oh, this is going to be a clear one, isn't it? All right, please don't do a close up. Oh, I was just saying, oh, well, okay, no, you can give us that. What are we seeing there, Keith?
We see the horn breaking up. So those are our lunar valleys and peaks, and those low spots where the light's shining through.
Yeah, it looks like a prominence as well there, doesn't it? Yeah, that
prominence too, that's letting that shine through, and it's just starting to form. Yeah, there it is. And we've got some beautiful color here. Wow, we've got prominences on the, this is great.
Gosh.
We've got a plage on the left.
Now, we were talking earlier about the hydrogen alpha view, which this is, versus a white light view. Hydrogen alpha, if this was totality during a total solar eclipse and you used a hydrogen alpha filter, you wouldn't see anything. It would just go black. And that's why astrophotographers get very, very nervous about photographing a total solar eclipse, because you have to take off your filter to be able to capture the sun, and that's when the sky goes dark. So this, Keith, the people who are there now, they're not even going to be noticing really that much dimming around them, are they? And it's certainly not going to be dark, and the sky is still going to be blue.
Yeah, you're not going to have, what we have during totality, but as I said, it has its own unique set of phenomena associated with it. And where else are you going to see something like, first of all, the beautiful color, prominences during eclipse? I mean, just great stuff. But no, you're right. We're not going to see the shadow banding that we would see during totality. You're not going to see, I don't think, the many images cast by leaves, because we are, I think, at about 0.9. If a total eclipse is 1, this was in the 0.9 range. So yeah, you're going to have.
Now, this one is looking.
This situation, it's not total either. Yeah, this is great. I mean,
you broke up there. I think this one looks more central, doesn't it? It looks like it's crossing from.
It looks
right
pretty even to me,
yeah.
And that beautiful ring of fire.
So we've got some comments with Slooh members who are in the webinar. Don't forget, if you are a Slooh member, you can always join us on air like this. People saying beautiful, holding my breath. It's poetic, Liz has just said, and others agreeing that yes, it is. And Jenny McLaughlin, she, oh my goodness, she almost gives a commentary while the Slooh Solar Telescope is online every weekday.
This is perfect.
And she's saying at the northeast is an image, it's an active region called AR3467, if anybody's interested. So Cloudy in Omaha, Sonal is saying, but enjoying the Slooh webinar. Thank you all. This is a terrific one, isn't it? This one, I don't think I've seen an H alpha annular shot like this before. I think that's marvelous. What do you think, Milton?
Absolutely holding my breath here, watching as moon progresses, its path between us and the sun.
Wow, this is beautiful, isn't it? Let's just take it in as we see this third contact. That was the stage that Keith was telling about. Well, it's third contact. So just when the limb of the moon crosses the edge of the sun. It's a beautiful one. Oh, this is going to look good with the horn effect, isn't it?
Yeah, these are just incredible images. I mean, the detail that we can see on the surface of the sun, being able to see granulation, and I mean, come on, this is insane. This is crazy. This is just
let's go back to the full view. We need the full view. Who's going to be the first to spot it? The official timing is 34:13 is when we're expecting. So 34:13. Let's see if we all agree on that.
This was perfectly placed. I mean, it entered in beautifully. It was right in the center, and now the moon is going to leave the sun. Wow.
And after the show, look up about the Valley of the Gods. It was the first time I'd heard about that location, but it's a pretty interesting place. So 34:13 is what we're looking at. I'm talking about the clock there. So 14 seconds. Oh, look at that. It's stunning. There it goes. It's going 14, 13. Oh, we need to see slightly further down.
Hey, people, don't forget to take a breath here.
Yeah, I wasn't. Yeah, there we
Oh,
go.
that's awesome.
That's it. That's
so
beautiful, isn't it?
perfect.
That
Really
is
perfect.
beautiful. Yeah. People saying, yep, it's gone, but we've still got another one. So we've got Slooh member Nick Rotundo is in El Dorado, Texas. Oh, that's interesting, isn't it?
Yeah, there's
So
our breaking up of the limb. Those are the evidence of the lunar irregularity, right? Those peaks and valleys and greater walls.
It's quite difficult to tell apart some of the smaller prominences that were on the sun versus maybe the view of the sun through those valleys, which we see as Bailey's beads, on a total solar eclipse. I'm not sure they could ever be called Bailey's beads in this because it's filtered, and Bailey's beads you tend to see in an unfiltered view, don't you, Keith?
There was a lot of speculation about this, a lot of internet chatter, whether you could even see them at all. People asking for advice on how to see them. If you look up, Wikipedia will say you're going to see them. And I had actually watched a live feed where we were in white light, and it did look like it was, in fact, it was the 2019 eclipse, and it was the feed from Singapore, Paul, that you had hosted. I thought I saw them in that feed.
Okay.
Beautiful, regardless of what they are.
Yeah, it is. And I guess, so much is going to change for phenomena like that, depending on the apparent size of the moon to the sun, because we've got this lovely cosmic coincidence, haven't we? That's why we see eclipses. I think, we see lots of occultations elsewhere in the solar system, but I don't think anywhere else would get a ring of fire type of eclipse or event, because this cosmic coincidence is, well, Keith, can you tell us about the cosmic coincidence of how we get total solar eclipses and eclipses so close to being like that?
Yeah, sure. So I think you're talking about the 400 ratio. So the sun is 400 times larger than the moon, but it's also 400 times further away. So the angular size, the size that they appear to us in the sky, is the same. And when we have a total eclipse, we can see that they're matched in size. But here, for the Ring of Fire, the moon is further away, so it appears a little bit smaller than the sun does. And as a result, the sun is not completely covered. It can also be, the moon can also be closer to us, and we don't have a perfect match. It's actually bigger than the sun, but we don't really get that effect because it's covering up the sun anyway. But that is the coincidence. When you get onto other planets, we do have these occultations, like you said, but their moons would have to be in exactly that ratio with the sun, and we don't really have that. What we would have is a transit where we would have, say, in Mars, Phobos or Deimos would pass in some eclipse. And true for other planets too.
Yeah. Well, we are, I think, 8 minutes away from our next annular phase. So, Gretchen, if we can anticipate that and put up Slooh member Nick Rotundo's feed. Nick, by the way, is going to join us shortly after that, we hope. We didn't want to get him on air at this. Oh, this is going to be great. Look, we can still see that prominence, can't we? Just up on the top right-hand side. So that's kind of, we can't see the edge of the sun at that point, but we can see the prominence still, which is just disappearing. Look at this. This is what I was hoping for. To have a little bit of light cloud, I said, please, just passing over. To me, that makes this look so much more flamier, right? If you like.
That seemed like it was cued on you. I'm like, is this what is happening here? It was like right when you said that. I love Nick's feed. It's so awesome that we saved this one. We saved it. Sorry, universe, that it was saved for last because of the color of his feed is going to be just absolutely brilliant when we get the ring.
This is the feed that Slooh members are snapping images from, and that's what they're going to use in their Eclipse posters in the quest. And I agree with you, Gretchen, the color of those, and also as you can notice as the clouds go over, it actually changes the color that the sun's looking. So these are going to be, I'm so looking forward to seeing those. So here we are. We're expecting this at 46:32. So we're about 6 minutes away on this one. We've got loads coming up, so don't go anywhere. By the way, Nick's so this particular feed is going to be, I think this is the longest, actually. I think this is the longest period of annularity. It's going to be about 5 minutes, 4 to 5 minutes. So that's going to be
5 minutes long.
Yeah. So we've got lots coming up, though. So immediately after that, we're going to talk to Nick and give him a huge thanks. We're hoping that we're going to meet and greet Russ Glenn, who is Slooh's professional development webinar manager. So that's going to be quite interesting to hear about that program. We've then got Dr. Kate Russo coming on, Eclipse Chaser Extraordinaire. And she's got a fascinating project that she's going to talk to us about called Project Ore. She's a psychologist, and she's been studying the effect that celestial events like this have, on people. And it's not just me who's brought to tears, during total solar eclipses. Happens a huge amount. We're also going to be talking to Bob Baer. He's at the Deb Initiative. We'll see how they got on today. We've got Steve Millam and hopefully some of his students who are at the Chaparral High School. They use Slooh, and hopefully they've started their Slooh posters today for this particular quest, and they're snapping images like crazy. We're going to be talking to Ron Hipschman. He is of the Exploratorium, who were the Ely and Valley of the Gods feeds. And then we've got some news coming up about upcoming events at Slooh. And then we've got one of our students who uses Slooh, Misha. Misha's going to give us a presentation about eclipses that she put together. So that's going to be a great way to see the end of the show. I do just want to mention as well, actually, that we've got another interview that we weren't able to pop into this. It turned out to be so interesting that it overran. So it's about a half-an-hour interview, but we're actually going to have a whole star party around that. Gretchen, tell us who and what that is about.
Okay, so really exciting. It was an interview I did with Dr. Sherilyn Morrow, and she's the outreach director for Punch, which is a project of NASA's. And she's in Chaco Canyon right now doing a lot of studies with phenomena, kind of connected with Milton looking at how people created architecture or petroglyphs or pictographs that correlated with the sun and the moon, and they've found one of interest there that actually might be a depiction of the 1096 eclipse that happened. Great, fascinating stuff. Chaco Canyon is also associated with equinoxes and eclipse and the changes in the sun and the moon. So in December, I'm going to bring her on for our solstice show, which will be perfect to talk about all of how the sun and the moon, how we're all connected, what that bridge is between ancient technology and what we have today. So super cool.
Looking forward to that. So thank you very much to Sherilyn for spending the time with us to do that. And sorry we couldn't squeeze it into this show, but my goodness, we are squeezing so much into this, not least 3 moments of annularity. So that is updating, isn't it, Gretchen? It hasn't been paused at all.
No, it still looks like it's still running.
Okay. So it's going to be interesting, Keith, to see how perfect this is. Now, I was interested, Milton, in we're using all of our feed partners and people like Nick are using special filters and telescopes to see this. We were talking earlier about Mayans being able to see this kind of thing. And there are other ways of seeing what's going on in eclipses, which is not looking towards the sun. So Keith, Gretchen, Milton, I'm talking about some of the phenomena that we see behind us. And Milton, I was kind of thinking the Mayans in the jungle, they must have seen one of the key effects very easily with that amount of foliage around. Can you tell us what happens there?
Of course, I'm sure that many of the observers probably caused the damage to the retina, but over the years they probably learned that eclipses can be watched when they happen, and the light goes through the foliage and is projected, let's say, on the floor. Therefore giving you the chance to see 1,000 eclipses at the same time, and it's just a mesmerizing view, really.
Yeah, and you can do it artificially with a colander, and you can do it during the partial phases as well. So you just hold a colander and have the sun coming from there, and then projected, like you said, on the ground or on a wall, you see hundreds of little crescents. So if Nick was doing that right now, he would see hundreds of those little sun-shaped crescents. I mean, isn't that a beautiful crescent? Look at that.
I love that. And you can even like do it with your hands.
Yeah.
Right? It's just any space that the light will shine through and project. I think that's like one of my favorite things to do is, you know, like you're waiting for totality or annularity, and then you're running around with your colander.
I think it's a great way of occupying kids during an eclipse, because you need to do something outside of the moment of annularity, the moment of totality, just to keep them engaged. And there's quite a few little exercises like that you can do, and that Keith was mentioning earlier, there are some other effects as well, like shadow banding. And don't forget that when I was telling you, what they're seeing now is this shadow racing across the countryside, and you can see it like that, especially if there's low cloud coverage. You can actually see the shadow on top of the cloud coming towards you. But look at this, 46 and 32. Oh, Nick, you've done us proud. Look at this. You've done us proud. There it goes. There it goes.
This is just amazing. How, you know, I just think this is so awesome too, that this is one of our members who's out there, you know, doing what we do.
There it goes. That's it,
Oh,
isn't it?
goodness.
Is that joined up, everyone?
I saw it like move. I saw it like, I know, I was getting so excited. I saw it like move past, and like the light just like boop.
Luke Russo is saying, yes, that's it. So, and Carol Botho, she's saying that her images are going to make a most stunning quilt.
Oh, right, you guys, if you're on, don't forget to get your pictures. Take your snaps.
Yeah, take your snaps, take your snaps.
You know, you start to like get caught up in this, and then you forget to take your picture.
Yeah.
As I watch this will forever go into my memory as the Halloween Ring of Fire eclipse.
Exactly.
Yes.
Because it's the Halloween colors. We're 2 weeks until that. Just wow. This is the best annular Ring of Fire eclipse I've ever seen. And 3 of them in a row, every feed absolutely stunning. This is perfect. Wow.
You know what's funny? Everybody was kind of quiet. Now we're all like, wow, this is like all excitement of it. It's amazing.
Nick's feed, I'm sorry, other event partners, but this is my favorite feed. Look at the graduation of the color in that, where it's brighter orange along the bottom and more fiery red at the top, and the clouds are staying away. Now that we've seen annularity, we don't mind if a few clouds come across, because that would be quite a nice effect. But look at this. Look at
it's
that
like
stark
stunning.
contrast between the
spot on
and the sun. And we're still seeing that huge prominence. So if you can see that kind of lump around the 2 o'clock position on the sun's disk, that's a huge prominence. It's superheated plasma and gas kind of being sculpted by a huge magnetic force field, that's force lines that are coming out from the edge of that. So how close is Nick then, Keith, to center line? It's looking pretty darn close to me.
Absolutely perfect.
So
I don't make these decisions, but Nick has the job. He's hired.
Yeah, absolutely hired.
He's hired.
He's hired. Yeah, I got you.
He just committed himself to all future celestial events.
We got Todd Riesel is joining us in chat as well. He said, beautiful, just got an image snap. Now Todd is an unsung hero.
With the prominence is fantastic.
Todd is an unsung hero at Slooh. He's been making sure that the servers don't fall over today, and he's done a great job Oh, look at that. Definitely my favorite. Definitely my favorite feed. We've seen the whole disk. We've seen the whole of Annularity occurring without going zooming in or anything like this. Beautiful job. Great job, Nick. Thank you so much. Oh, lots of people enjoying it in chat as well.
I can't wait to, when it gets dark, to turn off all the lights and watch the replay of this. This is just stunning.
Yeah. Yeah.
I may have to crop this and use it as a screensaver.
Yeah, excuse me. I've just gone full screen again. I forgot to go full screen. Oh, look at this. So you can see we're well past midway through. So Nick's got 4 or 5 minutes of Annularity. So we were talking about the types of eclipse, and I was talking about a very rare type, which is called a hybrid eclipse, where this ratio, these distances are so close during an eclipse that just the curvature of the Earth means that some areas the moon doesn't fully cover the sun's disk, so they land up with a ring of fire eclipse. But as the shadow comes further up, it turns into a total solar eclipse, and that's called hybrid eclipse, and those are very rare. The conditions for those have to be almost perfect, and you normally land up with a very short total phase of an eclipse during one of those. The one that we went to in Africa was 12 or 13 seconds. And I think Milton or Keith was saying this earlier. If you ever do go out eclipse watching yourself, never, ever give up. The clouds may part, and that's exactly what they did in Africa. So we were in the heart of Kenya for that eclipse, and it was cloudy, but just at the moment of totality, it came through the clouds, and it was the most spectacular thing I have ever witnessed by a long chalk. You cannot compare. And you've got to get, if you're in the United States of America, North America, frankly, if you're in the world, go to North America, get into the path of totality for the April 2024 eclipse. And if you can't get there, then for goodness sake, watch our live coverage, because we've got more of that coming up. Look at this. We're seeing that graduation of color again, aren't we? Wow. Oh, Nick must be so pleased. It is so nerve-wracking setting up a feed like this when you know the world is watching. But Nick, you've done it, mate. You've done it. Look at this. Oh, look at that breakup. That's the best breakup we've seen.
Yeah, this is great.
Oh, Nick, you've done a smashing job there. Still there. Still. No, that's gone, isn't it? Oh.
Yes.
Oh, good job. Kudos, Nick Rotundo, Slooh member in El Dorado, Texas. Thank you so much. I know we've still got, the remainder of the partial phases of this going, but my goodness, you've done us proud, Nick. Thank you so much. So, Nick, do join us whenever you like. If you can breathe yet, just take a breath. Just to remind you what we've got coming up. Hopefully Nick will join us to talk about the nerve-wracking experience of setting up a feed that the world is watching. We've got Russ Glenn, hopefully you're going to be joining us from Austin, Texas. Russ he's the leader of our professional development webinar series, because don't forget, schools use Slooh's robotic telescopes every single night to capture amazing celestial objects, and they use those in our learning activities called quests, where they learn about astronomy using telescopes in the same way that professionals do. Over the internet, they robotically control them from around the world. So we've got 2 observatories at the moment, one in the Canary Islands, high on a mountain, 8,000 feet altitude, that's 2,000 meters, at the Institute of Astrophysics of the Canary Islands. We've got another one in Chile, which shows us southern hemisphere skies in Chile, and that's at the Catholic University. And we are shortly going to be opening a new Australian observatory at Siding Springs. So we're looking forward to that. But anyway, we've got Russ, we've got Kate Russo joining us. She's a psychologist, an eclipse chaser. It's going to be interesting to see what she's been seeing today, because she's seen an annular phase. We've got Bob Baer from the Deb Initiative joining us, Steve Millam, and hopefully some of his students who use Slooh at the Chaparral High School in Scottsdale, Arizona. And what else we got? Yeah, we got Ron Hipschman coming from the Exploratorium, who gave us those other two terrific feeds. Gretchen's going to be telling us what's coming up at Slooh. And we've also got Slooh student Misha, who's going to give us an eclipse presentation. So unfortunately, a couple of the other students who were due to join us couldn't make it at the last minute. We were so looking forward to that. But if you haven't yet watched our Super Blue Moon show, don't forget, members, you can watch all of our previous star parties. Go back and have a look at the presentations that were made by two of our students, Kane and Grace. Absolutely amazing. I thought I was going to be out of a job. Frankly, if they turned up today, I would have left, because they're so professional. Their presentations were superb. So I don't know, are we going to get, is Nick going to be able to join us? I know he was short on bandwidth, and he didn't want to interrupt the feed if it was going to jeopardize anything. So Nick, do unmute if you, oh yes, you're there. Yes, Nick.
Hello.
Hi, you're a star. You're an absolute star. Thank you. The best feed by far. Thank you.
Well, thanks. I enjoyed the other two as well. They're all great.
What was the experience like? Nerve-wracking?
Yeah, absolutely. I just got the scope this week, so I had one time of testing my backyard. So
wow, but I
was
know
pretty,
you did. I know you were doing all the calculations of this particular telescope specification, this particular camera. Will we be able to see the whole disk? And you've done it. I think you've perfectly framed the sun for an annular eclipse. I think it's absolutely superb.
Well, thank you. Yeah, I definitely wanted to get a full disk view, because I have a white light filter as well for my refractor, but it wouldn't be a full disk, and that seemed to, it wouldn't have the full effect, I thought.
So somebody was asking about the equipment that you were using. So what are you using to video an event like this? Because I know there's going to be an awful lot of people who want to give this a try next April for the total solar eclipse.
Yeah, I'm using a Daystar Scout 60mm. So it's an all-in-one solar scope.
And a telescope like that, Nick, can only be used for the sun. You can't use it at night, can you?
No, not really, unless you take a 3-hour exposure for a dark image. But yeah, it's definitely.
So what kind of camera are you using then to take this stream?
I'm using my one of my astrophotography cameras. So it's an ASI 533, which is a square format, which I thought would also work really well with the circle. So.
Absolutely, it's absolutely perfect for that. So this is a high frame rate video camera, isn't it, rather than the very highly sensitive CCD cameras that we have for nighttime photography strapped to the back of Slooh's telescopes?
No, actually, this is I should be using a high frame rate, but no, I'm using the high sensitivity. This is the same one that I shoot my Orion Nebula with. And
okay.
Else, so.
Okay, so that's
yeah.
that's a nice thing for people to know, actually, that you can do something like this, but also be shooting nighttime as well on a normal telescope with it. Because I know loads of Slooh members are into astrophotography, and I know you're a member of the group who are sharing their own images that they process themselves.
Mm-hmm.
And you do some remarkable stuff. So highlight for you today, are you pleased with how this has gone, Nick?
Yeah, I thought it was great, and I appreciate the opportunity for sure.
Well, listen, it's been absolutely brilliant, and everybody, thanking you in the webinar chat. So thank you so much. Enjoy the rest of the time. We're going to see it out with you, aren't we? Which I think ends at 26 minutes past the next hour. Is that right?
If my batteries hold out.
Oh no. Well, listen, if they don't, rest assured you've given us exactly what we need, and all of the images that Slooh members have snapped are going to be turned into their beautiful Quest posters. So I think probably your particular feed of this annular eclipse is going to be, frankly, the most photographed and used anywhere in the world. So wow. Who's going to argue with that? Thank you, Nick. You're an absolute, so you're an absolute star. Thank you. Take care.
You too. Bye.
Wow. Team, what do you think, Keith? It's an amazing achievement, isn't it, to to have done this.
Yeah, I just am in awe and amazed and so glad. Can you imagine getting a telescope a few days ago and this is the result? I mean, that's like unheard of. That doesn't happen. I think if I bought a telescope 2 or 3 years ago, I would not even get anything close to this. So I'm just, wow, it's just amazing. And just the views and the color and this prominence that's still there, and just the framing, and he picked the perfect spot. It could not have been any better. Like I said, this is, I think, one of the best, I won't even say Ring of Fire eclipse. It's one of the best eclipse experiences that I think I've had here on Slooh. This was wonderful.
I agree. And I really like the orientation that Nick had. You know, this depends on the angle of the telescope and stuff like that. But the fact that he's framed it up so that the moon came in from the top and is now going over the bottom. I'm just thinking about members' posters now of all of their snapped images. And we're going to have all of these upside down horns, or they, you know, they're upside down now, but the ones before, the horns going up, and then it's going to transition to the circle, and then it's going to be, you know, these downward pointing horns. I think those posters are going to look so good. So
I'll tell you what I'm thinking. I'm thinking of, how about this, a second solar telescope, and he can take over. This can be like Texas 1 to take over for the solar telescope for the weekend. I think we can have a live solar feed. Maybe not every weekend, but maybe once a month. That
would be pretty cool. So lots of people in
I'm teasing Nick, I'm sorry, but it was that good. This was fantastic.
Exactly. So few comments in Slooh chat. Don't forget, if you are Slooh member, you can always join us in the webinar, so you can talk to us, give us questions directly. But welcome to everybody who's new to Slooh and watching on YouTube or elsewhere. Jenny is saying she stepped outside with her Eclipse glasses in Chattanooga, Tennessee, still minutes away from our 60% annularity view, she's saying.
Well, you know what, Paul, I just read that Nick's house is on the 2024 path. So, so Nick, when you're sharing your feed for our 2024, you just have to walk outside your back door. So, yay.
Wow. Hey, listen, I'm going to Nick's house. Yari's saying, Yari, by the way, if you members share images on Slooh with the rest of the community, make sure you look at Yari's images. Yari Backman, he's just saying superb, Nick, and you cannot, if Yari's saying that, there is no greater praise than that. And Jeff's got some screenshots. So what else have we got? Phoebe, we still have half an hour until maximum 55% here in Indiana. So when Phoebe's saying 55%, she's only having a 55% partial eclipse. She's not going to see annularity, which is going to be, this would be around, I guess, what we're seeing now. What do you reckon, folks? About 70, 80%, something like that. So an awful lot of people, if they're outside of that path of annularity that Dr. John Bovair was telling us about earlier, that's what they're seeing all the way through. They never get to see the annular phase. And don't forget what we were saying earlier. An annular eclipse is very, very different to a total eclipse. You know, this still looks spectacular, doesn't it? Even though it's a partial eclipse. The annular looked absolutely fabulous, so it's still worthwhile getting within that narrow band. But for total solar eclipse, if you are 1 yard outside of that shadow, that tiny speck of sunlight that is still visible means that it won't go dark, means that you won't see the sun's corona. It means you won't see all the planets and stars come out. You won't see huge prominences coming off the edge of the sun. You have to promise yourself one thing, because it is an event not to be missed. If you are in the USA, don't miss the opportunity. Get into the path of totality. Try and find out where the best weather is closest to you and get there. You won't regret it, I assure you. And if you do, you can write to me. Write me an angry letter. What else are people saying? Carol Botha down in South Africa. Great that you've been able to join us today, Carol, because I know that you've had a lot of brownouts and stuff like that in South Africa recently. So thankfully your power has stayed up. Thank you so much, Nick. This has been the most beautiful eclipse feed. We'll remember these moments forever. Thank you, Carol. And Nick is saying my actual house is in the 2024 path. we're definitely all going out to Nick's house, aren't we, for April 2024? The Slooh bus. And Hank saying, yep, I see you there. Phoebe is saying we're an hour from totality here in Indiana. So India is just north of center. So that's going to be an annular. So that's going to be pretty good. And Vincent Q is saying the same. Now, Keith, have you got anything else to add? We're going to welcome our next guest on very shortly, but have you got anything to add?
I do. Just thank you for inviting all of us to be part of this incredible event. I mean, I can't think of a more perfect way to spend a rainy afternoon around that. This was just wonderful. This one for the record books.
It is, for sure. Gretchen, we're going to speak to you later. Milton, thank you very much for joining us in this round table. We will no doubt see you on the member-led star parties that happen every week. So if you liked Milton's archaeo astronomy and some of those cultural and mythology bits and pieces, and make sure you join.
It's always a pleasure to connect the past to the present.
Oh, it is. I knew you were going to say it better than I did. So anyway, thank you very much, Milton. We'll see you very soon. Right, let's just take, actually, before we bring on our next guest, I wonder, Gretchen, if we could just take a quick zip through the feeds and then we will fix back on that. So there we go. Valley of the Gods, that's about a 50%, I would say. So their eclipse finishes in Valley, actually about an hour's time, I think. So you've still got plenty of time. Yeah, it's about an hour's time before that one finishes. We're going to be here for the full duration. There's Ely, Nevada. That's going to be finishing in just shortly in an hour. So you can see it takes about 2 hours for the sun to cross, sorry, for the moon to cross the face of the sun. But anyway, right, let's go back to Nick's feed because I want to welcome our next guest. And she's joined us for a number of eclipses, eclipse shows over the last, I think it must be 10 years. I'd like to welcome eclipse chaser and psychologist, Dr. Kate Russo. Kate, how are you? We haven't seen you for ages.
I know, it's been a long time, right?
It has, too long. Right, first of all, what kind of eclipse have you had so far? Because you've had your period of annularity. We're not going to block you from seeing that, are we?
It was pretty awesome. So we've had a bit of cloud. So we're on ground at in Uvalde County. We're in Garner State Park, and we've had a bit of cloud this morning. But the cloud has really, provided a bit of a filter for the eclipse. So it's been pretty cool. We've been able to catch snippets of it, and it's been great. And at Annularity, the cloud provided a bit of filter, so we could see it with the naked eye, and it was spectacular. It was so cool.
That's absolutely brilliant. We were saying earlier, because a lot of the feeds, so many of the areas have had kind of very light cloud, and we were all saying we actually think it makes the eclipse watching far more dynamic, especially when you're watching telescope views of it. But that's interesting that you had all of that. I just saw that you got some trees there as well. So was everybody's been looking at the different strange phenomena and stuff like that there?
Yeah, we've been sort of moving around a little bit. We've got a few stations. So I'm walking around now. We've got our canopy. I'll talk about the canopy actually while we're here. It wasn't as successful as what we thought it would be. We had, groups of people underneath able to look up at the same time. So it hasn't really worked out in the way. So I'm in it at the moment. Actually, it's working better than it was before.
You've got a special canopy set up to make that effect. Oh, that's a brilliant idea. So tell us about it.
It has been so cool. So it's a little project that we were trying to do here. We wanted to have a number of different canopies and to make them in different ways so we could get groups of people who can come underneath the shelter, and then with the mylar covering that we could all stand underneath. So if you look, I don't know, can you see? Hey, there we go. So that panel is, can you see that? All that panel, you're able to just look and stand, and that's the filter of the sun. So we had a whole group of people coming in. It was very cool. So that's quite exciting. But
a great idea.
We've got about 4 sun spotters. So during the partial phases, people were able to see sunspots, and we've got a few telescopes. There's eclipse chasers, so they were able to show about the colanders. We have trees on site, so I'll just spin around. And so people are sort of spread out a little bit, and we've got the trees on site, but I think because of the cloud, it wasn't really projecting that strongly to see the presence on the ground. And you know, I think in the last maybe 6 minutes or maybe 10 minutes before Annularity, it was really noticeable, the change in the light. So I was running around to everyone saying, you know, look around you, it's different, look at it. It's just, oh, it was great.
So we've been telling people, you know, because some of this is about the anticipation for the April 2024 eclipse. Were you able to see, we've been telling people, especially when you got some light cloud, were you able to see the shadow approaching?
No.
You weren't?
No,
okay, so that's interesting. So it wasn't dark enough to see that?
Well, I certainly didn't see it, but what we did see, because there was a bit of cloud over the sun, and that meant, over the eclipse, and that meant that we could see just in the final 4 minutes before Annularity, we could all just look, and it was magical. Like, it actually
brilliant,
sparkling, you know, like it was really cool.
So does that was that the moment? Is that the memory, that the moment that you're going to take away from this one?
I think so, because yeah, it is definitely, because it's seeing it with the naked eye. Of course, we know that during an annular eclipse, you really shouldn't look at it. You can't look at it because the sun is still there. But there was something about this one that with the clouds filtering, it was beautiful. It was almost like a diamond ring sort of thing. It was just so beautiful.
Now listen, Kate, let's take viewers back a step. So you've written books, you've been chasing, you are an eclipse chaser, you've written books about it. You study not eclipses so much, but the human reaction to eclipses. So just tell us a little bit about that background to kind of put some context on why you're here.
Well, I think first and foremost, you know, because I have a psychology background, I'm a psychologist. And when I first saw my first total solar eclipse, I was so surprised, and I knew that I was going to see them again and again. It just changed my life. I love them. I love them so much. And it took about, I don't know, 10 years before because I kept saying there's something unique about this experience, but there's also something very unique about the people. We are all similar, I think. We share the same philosophy on life. People are, you know, there's a lot of helping. There's that community sense amongst eclipse chasers, and our values seem to be very similar. So it's just really nice finding your tribe of eclipse chasers. But I was always very curious that there was some people who, like me, who you see an eclipse and then it changes your life, and other people who can see the same thing and they don't get obsessed about it. And I always use my hubby and you know, because I've seen more now, but he, you know, he loves it. He thinks it's pretty cool, but you know, so he's not as obsessed. So I was always very curious, what makes that different? Why is it that this happens to me, whereas it doesn't really happen to him? And so, you know, I'm interested in that, but I'm also interested in the experience of awe. And I'm a phenomenological researcher. And what that means is that I study the lived experience of things. And that means whenever someone experiences something quite profound or difficult or challenging, I delve into that to be able to look at, you know, what is it like? What happens? How do you make sense of that? And that approach is really good for studying the totality experience. So over the years, I've been doing that. You know, my first book was, it's 10 years ago. Can you believe that?
Really? Wow.
Yeah, 10 years ago. But that was Total Addiction, The Life of an Eclipse Chaser. And that really helped us understand the different phases that we go through during totality. And what was interesting is that people actually had very similar experiences in the same order or sequence. And so it was really fascinating as the moon moves in front of the sun, you know, that sudden change in the last 5 minutes, you know, with your annularity today, it's kind of at Annularity onwards, that's when it all happens.
Okay.
And, you know, having that sense of that eeriness, the weirdness, the primal fear that happens, and then that awe. So as the moon moves in front of the sun, you get the total eclipse, and it's just so awe-inspiring.
Yeah.
And awe is the amazing emotion that we feel. It's quite complex, and it's very challenging to understand how so many emotions can happen in a very short period of time. But we all experience awe there.
And it's overwhelming. It's to the point of it being totally overwhelming sometimes, isn't it?
Yes. Yeah. And because it makes you think about your life in a very different way. Normally we have a default mode that we're the center of how we think about things, but something like this allows us to consider our position in the universe, doesn't it? You know, that we see how vast the universe is, and we're a really insignificant part of that, but we're connected to something greater. And so that sense of connection and unity takes us away from those feelings of being, you know, considering all focused on the self. And that's what that's all about. And what's interesting is that the last 10 years, there's been a lot of research on the experience of awe. And this is the first time. So you probably noticed that I'm wearing a headset.
Yeah, I was going to ask you about this. Is this part of Project Awe, which is your new project?
Project Awe, who would have thought?
So what is this? What is this fashion item that you and others around you are wearing?
It's very fetching, right?
Very, very.
I'm glad you like it. So it's been a bit challenging with the headset. So this is a headset that captures EEGs from 5 different sensors in the brain.
Okay.
And what we know in laboratory studies and in functional MRI is that when we experience awe, it changes the way our brain lights up. So, you know, there's a lot of connectedness inside our brain that happens, and you can see this on MRIs. And usually the people are in a laboratory and they get shown photographs of awe-inspiring scenes, and then, you know, that even triggers the awe that we can capture the brain waves and the differences there. But this is the first time that we're looking at doing this in the field. And hey, what better time to capture that than during a total solar eclipse, right?
Wow. So this is a bit of a tester today then, is it, for the technology?
Yeah.
Okay, and it's going to give you a baseline presumably as well, but I guess it's going to be about the timing of it, because, you know, talking to other people, you know, the normal things that people are going to be doing while they're watching an eclipse, that itself. So are there particular signals that are the signal of awe that you say, oh yeah, there it is in the graph?
Yeah, so that's what we're trying to capture, and we're testing it today. And of course, we don't have that awe experience like we do during a total solar eclipse. But I must say, there was that point where, you know, when I started to see that you could see it unfiltered with the naked eye, and it was dazzling. It was beautiful. And I grabbed the microphone and I was telling everyone, and, you know, and then I made a comment of, you know, like, you can see that we're on Earth and there's the moon and the sun, and I got the goosebumps. And so there was definitely the awe there.
Okay.
And we had the ring of fire for about, I think it was 4 minutes, 55 seconds. So it was a long one, but it's not totality. So we're not expecting that the emotion of awe is going to be high for this eclipse, but you never know. So I've hooked up, there are 5 people who are hooked up, and I'm actually broadcasting mine live. So I can head on into the tent where I've got my research colleague, and he can actually show you, because this is recording, and there's a maybe 7-second delay to it being on screen. And actually anyone can log on to the website and see me sitting here talking to you, my heart rate, my brain activity.
Excellent. Excellent.
Shall we go in and talk to Drew? Actually show you things on
let's
the screen. Because I haven't actually seen what that was like, but he'll be able to pull up the moment of annularity, and let's see if that has made a difference in the readings from me. So there are 5 people across the site that have been that are hooked up, and I'm the one streaming live. Actually, there's 2 more streaming live. One, actually, the tech didn't go so well. but the other one worked okay. So I'm coming into the tent.
Okay. So how many people are you planning on hooking up for the April 2024 eclipse?
That's a question for Drew and I. We're still figuring that out.
Okay. Okay. So what can you show us? I'm going to have to shut up, otherwise the pip will come over to me. So you just show us what you can.
And so how are we going to do this? Because Drew's got a different.
Can you get your camera pointed to the screen?
Yeah, I've only done one so far, so I'm going to have to get the data off all the other phones.
But we're very keen to see what happened during the Ring of Fire with my readings.
Oh, with yours. So yours is, so I need to pull it over because our Wi-Fi was super slow. So it recorded it on the phone, but it was backed up in terms of presenting that online. So I do need to drag yours over before I can really talk about it.
Okay, so as you're doing that.
So Kate, go back while that's being set up. So you've set up this solar eclipse village at Uvalde County.
Yes.
And you said that the location's Garner State Park is very unique. Why did you set up there?
Well, they're in the crossroads for the today and April next year. So they're one of the few locations in the Texas crossroads where the path of annularity occurs over the path of totality.
Okay.
And during the April eclipse next year, we were really close to the center line at Garner State Park in Texas. And if you look at the path of totality that starts in Mexico and then up through Texas and then continues on to Canada, if people are wanting to stay in the US, then they would actually come to Texas, because what we know is that the weather is much, statistically better chances of seeing it in Texas. So given that it's the first one of the first counties that the moon's shadow sweeps across in the US, and also the proximity to the path of totality of the center line of the path. So we've got long duration, good chance of clear weather. It's beautiful in the Texas Hill Country region. Garner State Park is one of the most popular parks in Texas, and it's just great. And the people here on the ground are fantastic. There haven't been a lot of resources, but everyone has come together and really pulled something quite special in this solar eclipse village. And we're sort of, there's been some issues and concerns, but it's okay. Everyone's really having a good time with it. And there's just, what eclipses are like. It just has that feel.
It does. It's a vibe that's there, and there's an energy there. And what I particularly love, especially with a total solar eclipse, is the way that energy changes throughout the event. There's all of the anticipation of the partial phase starting, and then it tends to wane, especially when there are kids around. They're starting to get bored. So we were talking about, that's when you do the activity with the calendars and stuff like that, and all the shadow bands and all that kind of stuff. But then the excitement builds, and there's a lot of talking, but then there's, every time I've seen it, Kate, I don't know, you've seen so many more than I have, but there's this moment of almost stillness and silence where everybody looks rooted to the spot. Nobody talks. But then it's an explosion, usually at the diamond ring phase, and everybody starts whooping and just, it's an amazing roller coaster, isn't it? Witnessing a total solar eclipse.
Yeah, because it happens over such a short period of time. And it's like now there's such a great vibe. I think there was the vibe building up in the 5 minutes before. I was running around everywhere taking photos of people just enjoying it and just saying, look around, look at the light. This is so cool. Okay. And then when the cloud things happened, I mean, that was really quite special.
That's a blessing that happened, and so just to explain what Kate was saying there, because there's a safety thing there. You shouldn't be looking without eclipse glasses or filters at an annular solar eclipse or the partial phases of next year's total solar eclipse. But what happened for them today is there was so much cloud came over during that annular phase that the cloud itself acted like a filter, safe enough so that they could glance at that. It must have looked bizarre, actually, Kate, to see that with naked eye.
And in fact, I was with Lika. I had a pair of special filters on, and it actually looked like a partial oh sorry, it looked like totality through the filters with it. It
Really?
was quite
Yeah, so
strange.
that was the, it's kind of cool with the clouds.
So
Very
yeah, because the clouds are interesting. It's
know if you
very
can
hard to
see or not.
say, to see. But
Oh,
some-
yes, we can see it. Yeah.
and it's that perfect balance, isn't it? Of it had to be enough cloud to have that filter, but not too much to actually block the sun out.
Obscure
So
it.
it just perfectly aligned when we needed it to align. So,
So
are you
Kate-
ready for me to share
Yes.
Drew's?
Yes.
Okay, so
You can see without the glare here.
it's quite glary because we have a
have
partial
to get-
going on here.
Maybe
You'll
we'll
have
move
to
it
get that quite close up, I would think.
On my screen, I'm only seeing
a glare. Is that the, what is that?
yeah. So actually, Paul, we've got a sunspot from Nevada, from the feed from Nevada on our screen. So we actually can't see to project anything here.
We were seeing your screen then.
Oh, okay. So we can't.
Gretchen, I don't know if you can take off your screen share at the moment so that Kate.
Oh, is that
will
what
go
it is?
Full
Yeah, 'cause
screen. There we
can't-
go. That's done it. We've got you. Okay, so we can see the graph now.
Okay.
Right.
So you had to keep in mind this is Kate, and she was doing all kinds of stuff all day long. So what you're going to see is a lot of busy brain activity before and after. She's giving announcements. She's walking around. Let me describe to you really quickly what these emotions are. We have focus, which is going to be more of an outward engagement. So you're paying attention to what's out there and you're really involved in the moment externally. Motivation is going to be that balance measure. So enjoyment and interest in the moment. Arousal could be, it's going to be sensory arousal. So it could be excitement or it could be fear. And then inward attention is going to be, so that's this green one here. That would be more of a default mode network. So I'm kind of doing things on autopilot and I'm not really focusing. I'm just kind of in the moment inside my head. And then relaxation is exactly what that sounds like. It's just deactivation in all parts of the brain. So what you'll see before and after, there's a lot of variance here going on. And we just pulled Jesse's over and this was very similar for his. But this is what we expected to see right during the ring of fire here. You'll see there's a big peak in focus, a big peak in balance right there. So enjoyment and excitement, and then a big peak in arousal, her biggest peak around, and then a drop in that inward attention because now I'm not thinking about myself. I'm very engaged in the outer moment. And then relaxation, you'll see before and after was very high, but not during because she was completely engaged. So that's the exact pattern we would expect to see during that moment. Before and after, I can't account for what was going on there because she was running all over the place. But we did have about 3 minutes of high engagement and high enjoyment and high arousal there.
Oh, that's brilliant. If Gretchen, if we can go back to the normal screen share, but so we're really getting an insight into your brain there, Kate, aren't we? In a very big way.
Go to the website and people can look and see what's happening right now in my brain. Oh, he stopped it. Okay.
Yeah, I was going to say, make sure you're not like one of those politicians that still has an open mic when they leave an event.
Actually, that moment happened before because I got hooked up, heart rate monitor, sensors on, and I said, okay, before everything happens, I'll just quickly go to the bathroom so it's all done. And Drew's like, mark
that time.
But we have 5 people hooked up. So slowly we're getting the equipment off. But that's the first time I talked to Drew about what's happened. So yeah, kind of cool that you could sort of see. And that's only an annular. We expect it to be far more dramatic, obviously, during total, because it's what that's all about, and we're capturing the ore there. So it's a test run here. We're just testing to see how the process all works. So it's pretty exciting.
Is this the first time that this has been done, as far as you're aware?
As far as I'm aware, absolutely.
Wow.
Capturing ore in the field is quite new. The headsets, I think you can just get commercially. So, you know, they're the emotive headsets. We've got 5 sensors on. I think there's some with even more sensors, but the more sensors, it's the more data that you have to collect and collate. And there's programming that has to be written to interpret all this. So, you know, it's the capturing, but there's actually quite a lot of work behind the scenes to really interpret it properly, and that takes a little bit of time.
I'm going to ask you. I'm going to ask you about that in a sec. But I think one of the interesting things for me is, you know, what was very clear there was you were very active. You're talking to people, and you know, not focus on the eclipse. I think it's going to be really fascinating to see people who are not maybe being that active, but are more just taking the eclipse in, and
Absolutely.
to see the kind of changes there without the noise of other activities.
Yeah, that's what it's all about. So, you know, the people we will be recruiting for the big study in 24 obviously can't be someone like me who has multiple roles. Like today I'm running the show, I'm MC, I'm running outside, I'm doing everything here. And you know, you can't have that to look at ore. But today was just a little practice run of it. And we expect that people will be away from an event. We will be in a quiet place, that we're actually just reducing all those confounding variables, and we're focused on the experience of totality. So we have that build up afterwards, but it's that central moment of totality that we'd be especially interested in. So that's what we would aim to do. And I wouldn't be one of those participants there. That would be, and we haven't figured out whether it should be experienced eclipse chasers or people seeing their first total solar eclipse, because all these variables may impact upon levels of excitement and engagement.
Yeah, because the anticipation of an eclipse chaser who's seen it time and time again, but as you and I know, it doesn't matter how many times you experience totality, that peak is always going to be there, isn't it? However experienced you are.
And it's like you, Paul, you know, you say that every time you cry.
Yeah. I mean, that's what you need. You need a tear sensor as well, because frankly, mine's bucket loads every time I see it. But you know, I still can't get over it, Kate. You know, and we've talked about it so many times over the years. You know, and you use the word profound, and when I've tried to describe it, it's always been profound. And the other word I've always used, kind of unknowingly, and it's interesting, you know, what you're doing now. Or I've never really thought about, or I thought about it as a kind of word more than a pure, very separate type of emotion. But what are you going to do then with the data and the results that you gather up? Is this going to be a scientific paper? Is it going to feed into a new book? What's happening?
Well, it will be a paper. Like, this is an academic piece of work. So Drew is from the University of Tennessee in Chattanooga. And so, you know, going through formal processes. So it will be an academic study. And I think this is probably the first study of many, right? And, you know, it's just understanding the emotion of awe for one thing, because this will help us be able to look at the neurobiology of what happens to us during awe, you know, what happens in the brain, because we know that sense of connection and unity. And the studies are there that show the whole parts of the whole brain lights up. And we also know that the experience of awe leads to changes in people's behaviors. There's more gratitude. We feel, you know, we're more community driven. And so, you know, all these things we know about awe now. And that's what's really cool, because I used to be like a psychologist on this side, and then I'd go eclipse chasing over here. And, you know, I sort of was bridging the gap a bit. But now this focus on awe, and it's become the latest thing in psychology, actually. So in some ways, we're ahead. Well, because I just think, why isn't anyone else researching totality? And then, you know, you say that and think, well, actually, yeah, that should be me. I should be researching totality. So this is the next stage. And I suspect there's going to be more research that's coming out. And it's, you know, if you want to put a name to it, it's, let me think. What is the term? Neurophenomenology. There you go.
Neurophenomenology. That's a good one.
Neurophenomenology. So that's the thing, because it's about delving into the lived experience of the eclipse, but actually looking at the neuro things that are happening behind it. So this is new, this is novel, this is really exciting, and
It is.
it's been fantastic to be able to do it as part of the Solar Eclipse Village here. So
But thank you so much for sharing this, because, you know, a lot of our students are going to be fascinated by this. And it also shows, you know, what we always say, you know, astronomy and learning about astronomy. And there are so many things that are linked to it. And here, you know, just this understanding, or have a better understanding of this really core emotion. I was going to ask you, are there any other events that you can think of which incite such a great sense of awe as a total solar eclipse?
well, do you know, we can experience awe every day. You know, we can be in awe of someone or something, or things that are a bit more bigger and powerful than us, things that remind us that of our insignificance, but part of something greater. So you can get little moments of awe every day. And in fact, people say, psychologists are actually recognizing that doing awe, you know, finding awe every day is actually one of the best things you can do for your well-being. And so I think, you know, there are lots of opportunities to study awe and experience awe. But I think there's nothing like totality that has it in bucketfuls, right? It's just so intense. The seeing an aurora show, you know, like a massive one, October the 29th, 2003, was it? That one that was in the UK. Oh my God, I'll never forget it. That was awe-inspiring. It was incredible. So that those immersive things. But the thing about totality is that it's so immersive. And as I said,
it's so short as well. It's condensed over such a short period of time. You know, I saw one of the best auroral storms ever. It was my first, and everybody else who was more experienced and been seeing those things for 30 years, it was on actually one of our eclipse expeditions. And they said, Paul, don't ever bother trying to see another one, because you will never see one as great as this. But it was over 2 hours, Kate.
wow.
And it was awe-inspiring, but it just didn't have the peaks and troughs. It didn't have a beginning, middle, and end like a total solar eclipse.
Totality is just there. It's a sandwich. It's an awe sandwich. The best sandwich you could possibly think of.
I know. Kate, it's been fascinating to talk to you. Can you, kind of going back on the April 2024 tack and your experience as an eclipse chaser, seeing so many of these things, what recommendations would you give to any students or members or viewers at the moment for what they should do and how they should approach next year's eclipse to get the most enjoyment out of it?
I think, you know, there's a lot more resources now compared to before 2017. I mean, there were lots of resources then in the US, but there are so many resources now. So there are so many cool sites and educational things and practical things you can do. I liked the idea of just keeping an eye, like observing, being aware of the moon, being aware of the phases of the moon and observing the moon, because that gives you a sense of I guess celestial mechanics. It helps us understand that things that are happening outside of our sphere of our everyday life. And it's just that having the curiosity and openness to understanding, yes, this is a celestial event, but actually it's a bit more than that, isn't it? And you know, it comes with those profound experiences in a short period of time. So it is something that is different, and it is absolutely worth getting into the path of totality. So today's Annular is really good because I think all across the US, everybody's probably out there with their solar filters on, a partial eclipse. Some people in the path have seen the Annular Eclipse. We've had the Ring of Fire sort of on repeat, which is cool. Yeah. So everyone's sort of getting in the mood about it now, but it's really important to know that the Annular is interesting, but there is so much more. It's like, oh, there is so much more.
Yeah, we've had those conversations before. You know, I didn't really want to say it too much at the beginning of this event because I didn't really want to be downplaying what we were going to see today, but there is truly no comparison between an annular eclipse and totality, is there?
Yes, because it's the, you know, the phrase that I use is totality happens above you, around you, and within you. And, you know, an annular eclipse, it happens above you, some of the around you, you know, because we notice the changes of light. I wasn't aware of any changes of like insects or bird behaviors. Really? I wasn't aware of any of that. The temperature did drop. And there was a point, and I think that's where I was suddenly become aware that temperature dropped. And then it was around the time that I was having that conversation about that perfect alignment of you on the earth with the moon and the sun, and it's just the ring there. It's it's just something. I got the goosebumps. But you know, my other two annulars that I'd seen, I'd always felt cheated, you know, because you see it happens, and it's like, yeah, but it's just not quite, is it?
Yeah. Yeah, so definitely, you know, and we've been trying to say to people as well, you know, there's no point in being 1 yard outside of the path of totality, because a 99.999% partial still is nothing like that experience of totality. And of course, how long are you going to get at your location of totality, Kate, for 2024?
Oh, off the top, I should know this. I've got 4 minutes 28 seconds in my mind.
That sounds, it is quite a lengthy one, I think, isn't it?
Yeah. So that is something else, because the last few have been much briefer than that. So, oh my goodness, that's going to be great. And you know, I'm not going to be hooked up, so my intention is, of course, we're going to run the study. And Drew here, I don't think you've seen the total solar eclipse. So that's going to be hard for Drew, because you know,
you need to get him away from his keyboard so that he can experience it.
He's listening to it now. I'm telling you. So we've
exactly. Otherwise, it's going to be the same as me. You know, I've seen several total solar eclipses, but normally it's behind me because I'm on camera.
Don't do that. Don't do that.
Kate, it's been absolutely wonderful to see you again. You know, with all due respect to our other guests, I was looking forward to talking to you more than anything, because I knew, you know, a little bit about the project that you were doing, and it just sounded absolutely fascinating. And we look forward to kind of following up with you, you know, maybe before and after next year, because we'd love to know kind of some of the findings.
And people can actually go online. Like, Drew, what's the path, the website, because it's live.
Yeah, where can we go to for more info?
See my heart rate, my brain waves.
It's marathon-brainwaves.
Marathon-brainwaves. I'll actually add it into the chat here when we disconnect.
Brilliant. And that'll be shared in the community, and we'll certainly follow up with that. So
yes, it's no longer live though. No longer live, but some of the data is there. Oh, half an hour. Get on there now.
Oh, that's brilliant. That's brilliant. Kate and Drew, thank you so much for joining us today. It's really added on another perspective of our enjoyment of today's eclipse. So take care and happy eclipse chasing, Kate.
Thank you.
Take care. Bye now.
Thanks for beaming in. Bye.
Bye. Wow, that's always a great one, isn't it? It's always fascinating to listen to Kate, and do check out her books as well if you want a bit more of an understanding of what we were talking about there. And you know, if you're not going to take it from me, take it from Kate, who's an eclipse chaser. Totality is king. Don't miss an opportunity to see that. But anyway, right, let's have a look at our live feeds. We've got Ely, Nevada, 1741 is the UTC time, which is the universal time that astronomers use around the world, because you can coordinate all of these events around the world wherever you are. We've got 10 minutes left before that last little sliver of the moon moves away from the sun. Let's have a quick look awesome, Kate. We got some great comments about Kate's appearance there. Awesome, Kate. All sandwich, love that. Thanks, Kate. All sandwich is going to be a thing, I guess. Yes. And then we've got that URL that we can share in the Slooh community. So anyway, what are we up to now? Let's take a look through the feeds if we can, Gretchen. So this is Ely, Nevada. How are we doing at the Valley of the Gods? Okay, so that's looking pretty cool. Somebody did comment actually that the Ely feed has gone a little bit blurred. They may have some cloud. You know, maybe the person who's doing that feed is under so much stress they've collapsed. And the focus has gone out or something, but this is a good one as well. So Valley of the Gods is going to end at 1 minute past the hour. So that's going to be the second one where we lose the partial phase of the eclipse. But then, of course, we've still got our El Dorado, Texas feed. This is some Slooh member, Nick Rotundo. We spoke to him earlier. Everybody in chat was thanking him for the awesome feed. It's put a new inflection, hasn't it, on that word now. Awesome. Can we go back, Gretchen, to Nick's feed and have a look at that? And we will welcome in our next guest. We've seen some terrific images and feeds, and one of the feeds that we were hoping for was from a project called the Dynamic Eclipse Broadcast Initiative. And I'd like to welcome Bob Baer, who's a staff member in the School of Physics and Applied Physics at Southern Illinois University, where he directs public astronomy observations and provides technical research there. Bob, are you here? I can see you're here. Can you unmute? Can you hear me?
There we go. Can you hear me now, Paul?
Hi, Bob.
Hey.
Yes, we can. Good to see you.
Awesome.
How has your project been going? So I don't know if you just heard from Kate Russo and the research that they're doing in the psychology and measuring. It's fascinating. So what is your project then? You've got the Dynamic Eclipse Broadcast Initiative. What is it that you're setting out to do?
So, gosh, it's a big project. So we have telescopes all across North America today, Mexico, US, and Canada. And some of them have been broadcasting today.
Oh, yeah, we've got one on the screen now.
There you go.
Yeah.
So we've been sending some of our images, they're scaled down images back to deborah.physics.siu.edu, as you see there. And so those are coming in live from the telescopes. They run scripts and they send the images back live. But we're looking to study the solar corona again during the total solar eclipse.
Yep. So this is a dry run for you today, isn't it? And to go back kind of to the beginning, you say you've got all of these telescopes. Well, what you've done is you've equipped schools and students with identical telescopes and cameras and with the same software. So presumably all of the images are going to look, they're measurable, they're comparable.
They are. So for scientific purposes, we can take in that data, those images, and we can actually, align the image from site to site and make a movie out of all that. So what we're looking to do is make a movie of the solar corona, like our team did back in 2017.
So
and
the
you can
corona
actually see that. Yeah.
The corona
you can see
is
that
a word.
evolution. Yeah.
Okay. The corona is a term that we haven't used so far in this eclipse because it's an annular eclipse and you don't see the corona. Can you just tell viewers what the corona is?
So it's the atmosphere of the sun, and the part of it that we're looking at is the part that you can't see from NASA satellites like the Solar Dynamic Observatory. We can see not quite down to the surface of the sun with the satellites. You see the outer corona, and you can see the surface of the sun with those satellites. We're looking in between the surface, right down to the surface of the sun, out to about 3 times the diameter of the sun. Or about 3 times the radius of the sun. And so we can link what's happening on the surface of the sun with what NASA Solar Dynamics Observatory sees out farther.
That's fascinating. So this is not supplementing or just repeating something that can be better done with the space telescopes. This is something that can only be done by using the kind of equipment that you're equipping these students with.
That's right. So the ground observations are the best observations you can do during a total solar eclipse happen from the ground right now. And that's because the sky's darkened out and we can see right down to the surface of the sun because the moon blocks it out so perfectly. And we got just a little bit of a taste of that today. You could see the prominences if you had a hydrogen alpha telescope like we do here in Midland, Texas. You can see those prominences, and those are visible all the time. But to see the actual solar corona, you need the full sun blocked out. And it's pretty spectacular, as you know, Paul.
Yeah. So do you think today has been a successful test for you?
it's been very successful.
Excellent.
So as people who might have looked at the website online, not all the sites had images up. We've been rushing to get equipment out to the users and get people trained. We have equipment for 75 volunteer teams, and many of these teams haven't used telescopes before even. So we had about 30 teams that were imaging today, and those that were not able to upload have the data saved locally, so we can pull that data in. We're actually doing a little bit of scientific analysis on it. We're doing some lunar limb measurements with the images that we get right around Annularity. But yeah, I'm really happy with how today went.
Well, I'm glad that it's gone well. If there are schools and students who use Slooh who want to get involved in your projects, what do they need to do?
So go to debinitiative.org. We've got contact information there. And we've got a lot of teams so far. We can take on some more observation teams, and we can take on some more people to work on the core part of the project if some of your Slooh users would like to do that.
Okay. Well, I know that some of them would be rather interested in doing that. We've got one question for you here before I let you go. Hank is asking, what kind of equipment have you been giving the students?
So we use small 40 millimeter telescopes. They're ASCAR FMA 180 Pro telescopes specifically. We're using small Neptune Player 1 cameras, monochrome cameras. And then we have Skyhunter mounts, Ioptron Skyhunter mounts. But most, a lot of the amateur astronomers use their own mounts. The only other thing people need is a laptop. And for the DEB initiative, so we have NASA and National Science Foundation funding. So most of our teams get the equipment for free, actually, and they keep that equipment after the project to use for other follow-on projects.
That's great. And we're being told in chat that this is one of the DEB feeds coming in from Mexico.
Oh, yeah. I was really happy to see that. I think we have 3 teams in Mexico that we're going to try to take data today, and I think that might be the one from Guadalajara.
Okay. Listen, Bob, thank you so much for spending the time and joining us to tell us a little bit about your amazing project. And it's so well aligned with what Slooh are trying to do to get astronomy in the hands of more students. So we will keep in touch, certainly in the lead up to April 2024, and we wish you every success with your project.
Yep. Thank you, Paul.
Take care, Bob.
Bye.
Wow, isn't there some great stuff going on in the world out there right now? If you're into astronomy and stuff like that, if you're a student, don't forget, astronomy is a gateway science into so many other things. And my goodness, studying astronomy with live telescopes like you do at Slooh, that's a pretty cool way of doing things. Here we've got our live feed from Texas. How close are we? We are a minute away. Actually, if we go to Ely, Nevada, because we're about a minute away from just seeing the moon leave the sun's disk. And I would like to take this opportunity. We have talked a lot about schools and students who use Slooh's Quest learning activities and online telescopes to study astronomy. And I'd like to welcome one of them, Steve Millam, a teacher at the Chaparral High School in Scottsdale, Arizona. Hi, Steve.
Hey, Paul, how you doing?
We're doing really well. I mean, it's always great fun to do these, bit nerve-wracking, but it's always great fun. What's more important is, how have your students enjoyed their eclipse experience today? Because you've only had a partial eclipse.
Right. We had about 85% coverage, so that was very good. I was happy with that.
Okay. And did they enjoy it?
They did. I hate to say it, Paul, but they spent more time outside with my telescope and I got a sunspotter projector that took most attention. And also we looked at the shadows as well. So they spent more time outside than seeing the live coverage, but they enjoyed themselves.
Well, that's good. That's what they should be doing. So hopefully some of them have managed to snap some images to do the quest.
Well, I took some screenshots, so I'll share that with them too. So
excellent.
I made sure to get some screenshots.
Excellent. So what have you got? I'm interested to know, what have you got planned for 2024? A lot of this is building up the anticipation for the total solar eclipse? Are you doing anything at school, or how far away are you from the path of totality?
I don't know about 2024 because I'll be in Austin, Texas. So I'm going to go see it live. And I'm not sure what's going to happen here. Last time in 2017, the district actually, I don't like to say this, but they actually kept everybody inside because they're afraid of kids getting hurt and lawsuits and stuff like that. So
we heard a lot of that actually at the time, and we had a lot of schools watching, you know, playing in the hall, part of our coverage. So you can understand a certain reticence, but you know, I think if things are planned out properly, you can do all of this very safely.
I agree. I agree 100%.
So what kind of telescope did you have set up outside? Were you projecting?
I have a handmade 6-inch telescope, a Newtonian type. I have a solar filter. I had to scramble yesterday because I thought I had one custom fit for the size. Apparently not, so I had to take my bigger one and find ways to get it mounted on the telescope, but it worked. And so it's a professional grade filter that blocks like 99.999% of the light, and pitch black, just like the picture you see on the screen here, except for, you know, where the sun shows up. And we had great pictures of the prominences, the sunspots, the moon crossing, and the kids loved it. And they tried to take pictures with their cell phones through my eyepiece, and they probably did better than I did because people somehow know how to take pictures with their cell phones better than us old folks do.
That is always really difficult. It's something called afocal projection, when you're holding up a camera to an eyepiece on a telescope, and it has to be perfectly placed, otherwise you can't see it. But that's great because they've had that little bit of experience of actually trying to capture a celestial event like this. So tell us a little bit about how you're teaching astronomy at Chaparral. Do you teach astronomy for the whole year, or do you just do it a semester? A lot of places are just doing short courses. What do you do at Chaparral?
First, let me talk about the preparation, because it's called astrophysics on purpose because they have to take physics first.
Right.
So all the students I have are seniors. I had those students as juniors last year, and they're top-notch students. So they have a year of physics ahead of time, then they come and take astrophysics, and yes, it's a full year course. We start with the basics, and so I hate to say we're still kind of in the basics right now, but we're just about to start talking about telescopes, and then very soon we'll talk about spectra, which is one of my personal favorites, coming up pretty soon, and we'll talk about the sun as well, and you know, show a lot of these things and pull out telescopes as well. And we're going to use Slooh for a number of the quests. So I actually have one in mind that is kind of my own quest. I'm going to have the kids take a picture of each type of star, an O, B, A, F, G, K star on their own. They'll have to look up the stars and have them take a picture of it, and then we'll have them do nifty nebulas and probably the one as well. And I'm sure I'll do one of galaxies too if I can. So the kids are enjoying competing against each other, getting more gravity points.
Oh, they're into that. Okay.
Yeah, they are. And they're great. It was just scary. I can't let them beat me. I've actually threatened to cut off their Slooh account to keep them behind me, but we'll see.
If anybody is new to Slooh and they don't know what gravity points are, anything you do on Slooh earns you gravity points, and with gravity points you go up different levels of famous astronomer and things like this. But we also have school league tables that schools can opt in or out of, and that gets incredibly competitive. Steve, I don't know if your students have kind of looked at where Chaparral is in the overall leaderboard.
I can't remember for number 3 or number 7 at one point. I need to look that again.
Okay, well, I wish you well, and with a whole stack of new quests coming out, hopefully you'll boost your gravity points. But I'm so glad you all had such a fabulous time today, and we hope to see your students in April 2024, whatever you're doing, but we'll see you in Slooh in the meantime. So thank you, Steve. And I know that you're an inspirational teacher down there, so keep up the great work.
Thank you. My students give me a lot to be encouraged by, so it's an easy job when they have so much fun. Thank you, Paul.
It is. Take care, Steve.
Thanks. Bye from Arizona.
Thank you. Stephen Millam from the Chaparral High School in Scottsdale, Arizona. We were hoping to get some of the students on as well, but that's been difficult because they're probably still watching the eclipse outside. How fabulous to have the option of seeing the telescope and also seeing some of the feeds that we're getting here. We've still got our Texas feed up here. What's the next timeliness? So in 3 minutes time, we need to go over to the Valley of the Gods feed, because that's going to be finishing at 1 minute 46 past the hour. So that'll be a good one to see if we can spot the last little nip of the moon leaving the face of the sun. Now, what have we got coming up next? I've got to catch up. Goodness me, this has been an absolute firestorm of activity today. What is it? 3 hours? Have we been going? 3 hours? There you go. Anyway, we have been enjoying some absolutely stunning feeds from Nevada and Utah by our partners at the Exploratorium. And I'd like to welcome one of their house scientists, Ron Hipschman. Hope I've said your name right, Ron. Can you hear us and see us? How are you? It's muted at the moment.
There we go. How's that?
Great, you're coming in loud and clear. Now then, we've got to, please, Gretchen, pull up Valley of the Gods. While we've got Ron on, we've got to have their feed. Oh, look at this. Look at this, Ron. You've been giving us some absolutely fabulous feeds today. Are you pleased with how it's gone?
Well, I have to confess, I'm not in the Valley of the Gods. I'm in Ely, Nevada. So we're kind of finished up for the day. We had a great event here. We're at the Ely Railway Museum, and we had a lot of people show up here. I would imagine there were like 500 people showing up here.
Wow.
A lot of them showing up with their own telescopes. A lot of people had glasses. And we had a lot of demos here. We did, the usual pinhole projection, pegboard, and spaghetti strainer projections. We have a couple of sun spotters, and we're also broadcasting from Ely as well as the Valley of the Gods. We're kind of
we've been enjoying both of the feeds, the Ely feed and Valley of the Gods. So we've been watching both of them. They've been absolutely fabulous and showing very different things. A little bit worrying. Were you concerned at the beginning when there was all of that cloud? It was fairly light cloud, but nonetheless, it must be nerve-wracking.
It was not looking good. It was very high clouds, and they were getting worse at the beginning of the eclipse. So, but then all of a sudden they just went away.
Excellent. That's exactly
the eclipse gods work their magic.
We were saying earlier that actually, and we've got it now in the Valley of the Gods feed, a little bit of light cloud adds a little bit of a dynamic nature to the eclipse and the view of it. But here we can see this is a perfect time, that we've got you on. This is the end of the Exploratorium's coverage of this eclipse, just seconds away. It's always fascinating to see, can you spot when it's still there? We can still see it there, can't we, in the H alpha? Still see a little nibble taken out. I don't know how well you can see it on your screen, but
I can't see it at all. But I know the H alpha is a little bit, the sun is a little bit bigger in H alpha than it is visible.
There's 20 seconds to go. It's actually 6 seconds now. So any minute now, viewers, that's going to go. Ron, you've done a marvelous job providing us these feeds today. Tell us a little bit about the Exploratorium, though. Where is it, and can students who are using Slooh come along, and what can they see and do there?
I wanted to add that we're doing this in association with NASA. That's provided a lot of our funding to do this, and so they've been great partners with us, and we've been doing these eclipses with NASA since 1998, where we webcast from Aruba. And tough job, but somebody's got to do it, And back that time, we were using NASA satellites too. We used the TIDRIS system to broadcast, so that was kind of a cool thing to do. But we've been with NASA for a long time. The Exploratorium is a science museum that's located in San Francisco. We're at Pier 15 on the Embarcadero, so we're actually out on a pier, and we have which means we have a lot of interesting new things that we can do that we weren't able to do at our original location in the Palace of Fine Arts. So we have a lot of fun environmental stuff as well. We have 300,000 square feet of museum. lots of
Wow.
exhibits. People should definitely, when they visit San Francisco, should come out and visit us.
Excellent. So what have been the highlights of today for you, Ron?
Well, during the eclipse, I was kind of manning a table with, again, all the kind of the demo equipment, the pinholes and the spaghetti strainers and welding. Thus, you can tell we're at the Railway Museum.
Yeah, I just heard that.
They're just pulling a diesel engine back in now. They take people out on trains at night. So actually last night we were on the night train, and we were able to do nighttime stuff too, point out constellations with our lasers. And I gave a little presentation about eclipses on the train. I forgot the question. Oh, the things.
Your highlight for today.
My highlight. Well, we had so many ways to view the sun at our tables, our demo tables, that I was kind of running around between pinholes and spaghetti strainers and sun spotters and binocular projection, just trying to cover it all. It's all on my phone now, so we're all gonna, when we get back to the museum, we're gonna combine all of our archives together.
Oh, that'll be great.
We'll try to publish a gallery.
I was going to say that would be fabulous to see that. So listen, Ron, thank you so much for providing both of your feeds today. They really have been epic. And Valley of the Gods, that one, I don't know what telescope you're using there, but that was an absolutely wonderful.
Did you see, here's some of the telescopes that we're using here.
Oh, yes.
A similar set at Valley of the Gods. We have 4 different telescopes. We have a wide view of the sun in visible and H alpha. Then we have narrow views in visible and H alpha.
They look fabulous. So thank you very much, Ron, for joining us, taking the time. You must be exhausted after your day. So go and have some rest, clear the gear up.
We love it. We love it. It's exciting.
It is. So I can never sleep after I've done one of these. So, but anyway, it's been lovely to meet you, Ron. And thank you so much for providing the feeds with your partners at NASA.
Keep up the great work you guys do.
Thank you. Take care. Wow, this is a great event, isn't it, today? And we're not at the end yet, because as you can see, we've got our live feed here coming in from Slooh member Nick Rotundo. He is in El Dorado, Texas. We spoke to Nick earlier. Don't forget, if you missed any of the show, then you can watch all of our star parties on the Slooh website on demand. This one is also available on our YouTube channel as well, because we've been broadcasting to YouTube as well today. So if you're intrigued to know what goes on at Slooh and you're enjoying listening to some of this, and if you're still around, you must be. If you're interested in doing this kind of stuff, seeing live views of the sun through Slooh's special H alpha telescope that we've got in the Canary Islands, the nighttime telescopes in the Canary Islands, the new telescope that's going to be in there by the end of the year, the new Australian observatory that's coming out soon, and the Chile observatory. If you're interested in doing all of that, then maybe check out www.slooh.com. Come and join the community, because I'll tell you, it really is a great community of both members and students and schools and teachers. And we've spoken to some of our educators today, and gosh, they're an inspirational lot. I wish I had science teachers like that when I was a kid. But anyway, talking of these people, there are a handful of hidden heroes behind our event today. I've already mentioned a few of them, but here's one of them, our events manager, Gretchen Bickert, who is going to tell us about what is coming up at Slooh. Gretchen, what's coming up at Slooh?
Hey, Paul, thank you. Wow, what a fantastic event. Oh my gosh, so much fun, great weather, great feeds, great people. I loved it. So coming up, we have more excitement stuff. A really big highlight I want people to know about is Russ Glenn, who's an amazing educator, is putting on a series of 4 webinars focusing on eclipse. The first 2 were the annular, and now the next 2 will be for the total. So this really teaches teachers how to teach about this eclipse, right? So how do you use Slooh and all of its tools, the telescopes? His webinars will have demos using the robotic telescopes. There'll be homework and activities and all sorts of information so that students can really get the most out of the eclipse, and allow teachers to use Slooh to get the most.
And teachers get some professional development credit as well. when they've gone through them.
Yeah, there will absolutely, there will be credits, CEs for them. So the next one's the 25th of October, which is coming right up. And then the 8th of November. They're on Wednesdays at 8 o'clock Eastern time.
And if any teachers are kind of joining late, and if you're out there, you know a teacher, tell them about this particular program that we've got. And it's not too late. They join up with Slooh. Their students obviously can use Slooh as well. But you can watch Russ's first 2 episodes of that professional development course on demand on the website. So, but the next 2 are going to be the really important ones: how to teach about the April 2024 eclipse. We're not even past this one, Gretchen, and we're already looking ahead. So what else?
I know, because we're all excited, right?
Exactly.
We're all excited.
Yes. Exactly.
So so that's coming up, and I encourage you to sign up. And like Paul said, if you missed the first 2, you can catch the replays. I was there for both of those. Super engaging, really exciting. Learned a lot. Also, we've got, of course, Dr. John Bovera, who everybody saw at the beginning of the show. He has his educational webinars. I'd have to look to see when the next one is coming out. Check out on the website. And we've got monthly with the University of Maine on Thursdays at 7 Eastern. And that is University of Maine. Sean Latch brings us like an online live planetarium show. I love it. It's so fun, shows like the diagrams with the pictures of the constellations and what's up in the sky. Super fun. Love it. Great thing to check out. And then of course we have our members, our regulars members star parties that everybody can come to Tuesdays at 8, every Tuesdays at 8, easy to remember, 8 Eastern. And then first and third Sundays, we have Sunday Space Chat. That's on Discord, and that's a lot of fun too. So check it out.
That's going to be interesting. That's going to be interesting next week, Tuesdays at 8, because I'm sure everybody's going to be sharing some of their best eclipse images and posters and stuff like that. The next Using Slooh in Education webinar with Dr. John Bovera is on Wednesday 18th. So it's this week.
Perfect. It's next week. Okay, sign up and join us.
Yeah. And of course, we've got lots of celestial events. In fact, Gretchen and I are next week, we're starting on the new program, which is going to extend into 2024. We're going to be going back to doing far more live celestial events. So students and members can follow the ebb and flow of what's going on in the night sky. It's pretty cool. It's a pretty cool thing to do, isn't it, Gretchen? Have we got the best job in the world? I know it's been a bit stressful the last 2 months, but
you know what? Here's the thing. You get to be involved with the creation and sharing these with the world. I remember Keith saying, here's the thing. We get to share this with all sorts of people across the world who can't see it, right? Yeah. It's not visible for them. And then all the great people you get to meet. Yeah. Best job in the world. High five.
Yeah,
I agree.
Not bad. Thank you very much for that, Gretchen. Now, hold on here. I'm going to just do a little bit of a wrap, but we have still got one thing left for us today. We were hoping, we had planned and scheduled several students to be joining us today as expert guests. Unfortunately, 2 of them had to drop out because they couldn't get here live, but one of the other students couldn't make it live. But what she has done is she's recorded a presentation. This is one of our student members from India, and Gretchen will introduce that after I've kind of wrapped us up now. But it is time to, so we're still going on. We're going to go all the way until the moon leaves the face of the sun in that live feed from Texas, and that happens at 26 minutes past the hour. So we're going to stick with that anyway, and we're going to play this presentation so you can watch that presentation. But for now, I would like to kind of wrap the formal part of the star party up, and I'd like to thank our guest, Dr. Kate Russo, eclipse chaser, psychologist, Project OR founder. That's going to be an interesting one to look up and have another look at. We had Steve Millen, teacher at Chaparral High School, Scottsdale, telling us about how his students been using Slooh, but also the fact that they've been at the school today enjoying the eclipse live there, and they actually got to look through the special telescope that they had set up. We were hoping to speak to Russ Glenn, who is an educator and Slooh professional development leader. If we can go back to the live feed, if we can, that would be good, because we don't want to miss any of that. And anyway, so we couldn't speak to Russ, unfortunately, but please come and join us for his professional development program. We spoke to Dr. John Bovair at the beginning of this 3-hour marathon. Dr. John Bovair is Slooh's director of curriculum. He told us about Slooh Quest. He told us about a special quest that members are going to be using these images for. So I'm really looking forward to seeing some of those. But he also gave us that great Eclipse 101 as well, which is always a good thing to do. Keith Wozalewski, Slooh member and educator, thank you so much. Keith, it's always insightful to hear from you. Keith also ran the Slooh astronomy camp this summer, which was incredibly popular. And students, if you want to go back and have a look at the material that they covered, because there was kind of a moon week, a sun week, galaxy week, and stuff like that, all of those are available for you to watch as well on demand on the website. Milton Villarreal, always fascinating to hear Milton's stories. Archaeoastronomy. Do have a look at the blue supermoon star party we did a month or so ago, and listen to the story of the Jaguar. I love that. I love that story. So anyway, thank you very much, Milton, for sharing all of that. We spoke to Bob Baer from the Dynamic Eclipse Broadcast Initiative. We couldn't find any of the live feeds that Bob's students and schools were using, but that's a fascinating project as well. And hopefully some of our Slooh student members and schools might be able to get involved with that project for the April 2024 eclipse as well. We also spoke to Ron Hipschman from the Exploratorium. They're working in partnership with NASA. They provided 2 of our feeds today. I have to say, the Valley of the Gods feed, that was, pretty nice. Still think actually my favorite is Nick's one, the one that we're still looking at the moment. Slooh member Nick, still seeing that lovely prominence off the right hand edge. That's going to be interesting to see on Monday, see if we can still see that in Slooh's Canary Islands Observatory. And of course, I would also like to thank Gretchen Pickard, Slooh's event manager, who you've seen coming in and out of the event today. Thank our feed partners, the Exploratorium. There was Ron Hipschman, but also he's working with Robin Higdon as well. And Deb Initiative, Bob Baer, providing their images, and of course Slooh member Nick Rotundo. Thank you so much. Now I'm going to formally wind up my part of the show, because we're going to hand over to the most important people at Slooh, the students who use Slooh, and maybe Gretchen can introduce the marvelous presentation by one of our student members in India called Misha. But for now, for me, it's goodbye. Thank you so much for joining us, but make sure you hang around and watch Misha's presentation.
Thanks, Paul. It was a great show. I'm going to have to do another share so I can get Misha's presentation up here. But you guys, this is a presentation from a student, as Paul said, Misha, and it is all about solar eclipses, and it's just great stuff. So let's just go ahead and get that shared right there, and you can watch Misha's presentation as you also watch the end of the feed with Nick.
Greetings to everyone present here in the annual solar eclipse star party. I
don't think we shared the sound. Yep, we did. Okay, perfect. All right, let's just hold on and take 2.
Serene, a student in grade 10th in India, and I'm an astronomy enthusiast. Firstly, I would like to extend my sincere apologies for not being able to be in person here today. However, I'm truly excited and honored for getting this opportunity to present to you remotely about this captivating annual solar eclipse. So despite the distance that separates all of us, I assure you that this presentation is very intriguing and it has the shared passion for the celestial marvel. So let us get right into this cosmic journey. I would be covering the historical front of solar eclipses, and these topics might include things like eclipse chasing, navigation and exploration, mythology and folklore, influence on calendars, historical records and documentations, the significance of culture and religion on solar eclipses, etc. So the first topic is mythology and folklore. So in ancient times, solar eclipses held significant places in the mythologies and folklores of various cultures. So many ancient societies regarded these celestial events as divine messages. So for instance, in ancient China, there was a belief that the dragon was actually consuming the sun during an eclipse. So to ward off this celestial threat, people used to create loud noises. This highlights that ancient cultures actually assigned spiritual or supernatural meanings to these eclipses rather than going to the scientific front. So they incorporated them into their belief systems and faiths to protect them against these perceived cosmic dangers and to pass on the way to guard themselves on various generations. So the scientific advancements made in regard of solar eclipses are actually quite less when compared to the historical record of solar eclipses. However, they have played a very crucial role in enhancing our knowledge of astronomy and the workings of the solar system as a whole. So a notable instance is the solar eclipse of 1919, which served as the practical demonstration confirming Albert Einstein's general theory of relativity. So solar eclipses and eclipses in general were the modern day Google Maps. So basically, they were highly practical in the fields of exploration and navigation. Renowned explorers like Christopher Columbus itself utilized eclipses as a means to calculate their longitude while navigating at sea, which enabled them to plot their routes with precision and make significant discoveries. Also in the contemporary era, total solar eclipses were relatively rarer events and they were in a specific location. So they were a magnet for travelers. So basically, in today's world, we have Slooh, and we can all connect as long as we have an internet connection and bond on the collective love for astronomy and our passion for it. However, in the past, there was no such facility, and it made eclipse chasing a very common, popular pursuit among astronomy enthusiasts, tourists, and researchers. And it not only satisfied their curiosity, but also fostered a deep sense of awe and profound connection to the cosmos. So eclipses have held various cultural interpretations ranging from spiritual significances to foretelling future events, demonstrating their profound impact on human societies throughout history. So they left their mark on cultural customs and traditions in diverse societies. So some cultures regarded them as opportunities for introspection, meditation, or prayer, while others considered them as evil moments, taking precautions to fend off malevolent forces. So they often bore significance as omens as well in various cultures. For example, in ancient Egypt, solar eclipses were interpreted as occasions for divine intervention in human matters. So notably, the renowned solar eclipse of 763 BCE was documented by Assyrian texts, portraying it as a foreboding sign of things to come for the kingdom. So there were three main ways where we saw historical records and documentations of solar eclipses, which were clay tablets, scrolls, and manuscripts. So these were actually very valuable as they showed us the mathematical and astronomical capabilities of the ancient civilizations and helped us make predictions for the same. It also helped us reconstruct timelines and help us avoid certain steps as well as advance in the field of eclipses as well as in astronomy as a whole, because we knew which steps to avoid as well as what can make our life easier, how can we predict solar eclipses similar in the way of ancient times, and etc. So lastly, we have public engagement, and this Slooh Star Party is actually an example of the modern public engagement related to solar eclipses. However, in the contemporary era, total solar eclipses were very infrequent in number, and they were in one particular region most of the time. So they had transformed into highly anticipated gatherings that drew tourists and eclipse enthusiasts from across the globe. And these communities, situated along the path of totality, frequently enjoyed economic advantages as well from their role as hosts to eclipse spectators, which cultivated a shared sense of awe and heightened scientific curiosity. So these are some pictures I clicked during the Slooh solar eclipse star parties. And the top left one was my first ever picture clicked in regard of a solar eclipse, and I still remember that I was awestruck, rather starstruck, when I saw my first solar eclipse. Even if it was via a telescope which was online, it was actually very captivating to see it, and I did learn a lot about solar eclipses that day, and I would be forever grateful to that one star party. So in conclusion, solar eclipses are actually not only important for the scientific contributions, but they have various cultural, educational, inspirational, and historic values hidden in them. And they serve as reminders of our place in the cosmos and an ongoing quest to comprehend the mysteries of the universe. So it is true, as they say, that the universe is not only vast, it's a canvas of endless possibilities. So with this, I would like to finish my presentation. I hope you all could understand what I was trying to convey via this presentation and could learn a lot more about solar eclipses. Thank you so much and have a wonderful day ahead.
Wow, how good was that? Thank you very much, Misha. It's such a pity that Misha couldn't join us live, or Grace or Kane or any of the other students that we were hoping to have on live today. But make sure you have a look back at that blue supermoon, because two of the presentations there are absolutely brilliant. So we are getting so close. I can't not just hang around for the next 2 minutes, because the eclipse, our eclipse, is officially ending when that last little sliver of the moon disappears from the sun, and that is due to happen at 26 and 16 seconds past the hour. So Gretchen's just
hey Paul,
yes.
Guess what? Nick's battery just died.
I know he was swapping it over just at the last minute, but frankly, I think members can snap that image and that is enough to finish off the entire event and their eclipse post.
I love it. I love it.
Yeah, that's you. Thanks, Nick. You've done a brilliant job. I doubt whether he can hear us. He's sitting there. He's cut off from the world. But that really does wind up today's Slooh Ring of Fire Annular Eclipse coverage. Thank you to all of our partners, to everybody who's been involved in the event. It's been an absolutely splendid one. 3.5 hours. Time flies when you're having fun. I hope to see you over in the Slooh community. Take care, everybody, until the next eclipse. Bye, everyone.